What's going on, everybody? Welcome to part 1.1 of trying to build a theoretical post-Saturn launch vehicle in KSP. I am EJ, your host with the most. So, I tried doing part 1 yesterday, and everybody wanted to talk about Ship 36, including myself. So we ended up doing that yesterday. So that 1.1 is probably not, that part 1 is probably not a good part 1. Today we'll, now that it's all kind of calmed down,
Discovery, go at throttle up.
we will work on these vehicles, this vehicle now, and we'll do it today. Agavidi 70-month resub, finally some good content. You know what? You know what? You know what? It's fine. It's fine. I agree. It is good content. It's part 0.00001. No, just 1.1. Just 10th of a decimal point. We're good. We're good. Hello, welcome back to the living. Hope you're feeling better. I do feel a lot better today. I can move without pain. I can't move very fast, but I can move. Yeah, I'm good, dudes. Hanging on the inversion table with some prescribed prescriptions from my doctor. As yeah, definitely, I'm all right. We'll be okay. Thank God.
Go at throttle up.
Beam had an update. I am not using the racing rig, dude. No, I'm not trying to move that. Not right now. I can't lift anything, dude. I'm gonna try to take it easy during the weekend, and then next week, if my back is cooperating, we'll get back to working on the Coronet. Poison A, 50-month resub. How's old Titan? How's Titan handling old Pops? Dude, I usually try to, walk the dog and play with the dog in the morning when Brimo's working. So when Bree is off work, she can play with the dog. 'Cause Titan's a worker dog. He has a lot of energy. You wouldn't tell by it when he comes in here. When he comes in here, he's very chill. But that dog, yeah, when that dog gets riled up, he gets riled up and he doesn't stop. So, it's fine. Yeah, I gotta rest up, and it's killing me not working the car because I want to work on it because we got the leaf spring hanger and everything, and it's okay. Hey, Mats, what's going on? I wish the Apollo applications program would actually happen to its full extent. I mean, yeah, me too, Methane. That's always, I think an Apollo applications program could be done with SLS, to be honest with you. That's always why I've argued that I want the SLS to work more, Because, dude, to be 100% honest with you, the core stage, 4 engines, and the 5-segment boosters is you got a pretty good throw with that. You got a pretty damn good throw with that thing. Now, if it was up to me, what I would be doing is basically using SLS for an applications program, but the applications program here would be focused around flybys around Mars, flybys around Venus. Basically pick up where the Apollo program left off. Convert here. I'll show you. And this has to do with the vehicle that we're going to work on. So this is pertinent. We're not getting too far off the rails here. So, look, you got a lot of, you can do a lot with, here, give me one second, with SLS in its, in these configurations alone, heck, not even these configurations, with Block 1B crew and cargo, with these two right here, you could get a lot done. Heck, you wouldn't even need the crew one, and for the cargo one, just take Orion's nose cone and put it right here. And then you almost got that fairing. There's no need to reinvent the wheel. You already made a fairing right here, right? Or better yet, build the 5-meter fairing up here so you could, carry the rocket aerodynamics wouldn't change much. So you do have a little, like a bottle-shaped fairing, but hey, whatever. You can do stuff with that. Now, here's what I would do. With these two vehicles right here, I would take the upper stage. Now, if you notice, Block 1 has a little bit of a different upper stage than Block 1B. Block 1B, it doesn't taper in to the ICPS. We have the exploration upper stage. The exploration upper stage, you know, it doesn't have the kind of the good TWR that I'm really looking for, but you know, it's already in the works, and you know, we could put it to use. What I would do with this thing is work on building this thing into a flyby and transfer vehicle. So with the SLS 1B crew stuff, and maybe, you know, maybe we'll do this in Kerbal when we're done building the post-Apollo vehicle, right? I mean, I don't see why we would, but I'll do it to demonstrate the point. Yeah. Did the rust clearing off that pipe with the grinder go well the other day? Off of the pipe? What pipe? Which pipe are you talking about? 1B have funding now? It should be. I'll admit, I talked to one of my buddies that worked down at Michoud about this a little while back. We haven't heard anything about the EUS, but they are building flight articles for it now. It did pass CDR. Test articles have been made, and they should be working on a flight version of it soon. So what I would do with this thing, with SLS, is not use it to build something. That's dumb. Why would you do that? That's such a fragmented architecture. Don't carry a transfer vehicle in here somewhere. That makes no sense. Like, don't carry gateway modules in this part. So SLS has a gigantic 8.4 meter fairing right here. This is basically a gigantic payload bay, right? And what they wanted to do was move gateway components inside of it. And you know, that's not a bad idea. I don't mind that, using Orion to basically build the transfer vehicle. What I really don't understand is why you're going to build a transfer vehicle that's going to be a prototype to go to Mars with solar electric propulsion when you have this, when you have the exploration upper stage in itself. Focus on boil-off mitigation technologies and refueling with the EUS. Take the universal stage adapter and then convert that into, put a HAB module on it that basically builds the transfer vehicle, or builds the EUS out into a transfer vehicle in itself. So you have basically a space station module with a docking adapter on here. Like, put Vast's Haven 1 in here. Attach it to the EUS. And have Haven 1, right, with its propulsion module over on the backside, be able to move this thing around and have it act as one gigantic transfer vehicle. And then have Orion dock to the Haven 1 EUS transfer vehicle with Gigantor solar panels here, and maybe I don't know, a fold-out solar shield to shield the propellants from boil-off or whatever, right? Work off boil-off mitigation technologies, and then use this as your transfer vehicle to do flybys around Mars and flybys around Venus, crewed. Now, you want to test this out? You want to make sure that this thing works? Okay, launch an SLS up there with the version of this, with just this version, passivate the tanks in LEO, and then go from there. And then use it as an ISS replacement, at least an interim one. Then send another one of these out to the moon, and then use that as your gateway. Use that as gateway. Make one that has a double docking ring on it, so you could dock here or you could dock there. Then you could put a Starship on it and an Orion on it, and use it to do gateway stuff. And then when you're done with that, you know, maybe SpaceX and Blue Origin have a good logistical pathway to the moon, right? When we're done with that, use that to
Discovery, go at throttle.
Use this to do the flybys, and then now you know how to do a flyby around you know, Mars or Venus, and then, you know, in 5 to 10 years, right? You could take this thing, if you use it to work on you know, do boil-off mitigation experiments during these types of flybys, right? You do the boil-off mitigation experiments, and then once you have boil-off mitigated with Hydrolox technology, send one of these out there uncrewed and have it circularize around Mars. And then you have a space station around Mars, and then you can land on Mars. Like, I've always said, building out the SLS isn't a bad vehicle. It just needs the right architecture. The problem is the architecture is dog crap. That's the big problem. You could do a lot with this thing. You could do a lot with in a very short amount of time. I'll probably do this architecture out in KSP at some point, Nova, just to show it can be done. I got to build out an Orion and stuff, but whatever. Solar sailing would be more effective until the boil-off mitigation technique has gotten up to snuff. Yeah, hard disagree, Stuart. No, I don't think so at all. What you're talking about is putting a sail on a train and saying like, oh yeah, that's more efficient. No, it's not. No. Steam is the most efficient. Or diesel electric. In this case, it's steam. Hydrogen and oxygen. What do you think's coming out of the back of those nozzles? The more you know. Do you feel like we should be focused on LEO manufacturing and asteroid mining to bring infrastructure to go beyond the moon before heading out to Mars? No. No, Cornbread, that is a technological dead end if we can't live on Mars, or if we don't have any... It's a technological dead end if that's all we do. Great, you got an asteroid. Now what are you going to do with it? That's why the asteroid redirect I always thought was a stupid program. I hated it. I hated it then, I still hate it. It was a stupid idea. Because that would be like Apollo taking the Skylab missions and saying a Skylab mission is more important than going to the moon. Right? No, it's not. It's not. Okay, you build a Skylab, now you're stuck in LEO. I always think that you should design your architecture with your quote-unquote final destination in mind. Apollo did that. The final destination was the moon in this particular case. But that doesn't mean that you couldn't use it to go other places. Right? What I'm saying is do that transfer architecture that I just talked about, right? Do the transfer architecture that I just talked about, and then use this to go mine. Because mining an asteroid, great. So if you do an asteroid redirect and you bring an asteroid into lunar orbit, that anything that's worth mining, right? That, okay, great. You can mine it. What are you going to do with all that material? Where does it go? Asteroid redirects and asteroid mining is there to supplement your industrial base. Like if you bring an asteroid out onto the moon, the only reason why we do that is you're either on-orbit manufacturing, which you could do. You could prototype that with this architecture that I just told you about. Or you could redirect one and have it around Mars. You have it around Mars, you have a near infinite tap. Right? But in order to do that, you need a base on Mars. Or you need some type of orbital infrastructure. Right? And the point is that going right to the asteroid is like... Going right to the asteroid would be like setting up a gold mine, right? Because the asteroids are like theoretical gold mines. You can set up a gold mine, but then you have no way to move all your resources. The only way a gold mine doesn't exist in a vacuum. And no mine does. Pit mine, coal mine, gypsum mine, quartz mine, whatever. It doesn't exist in a vacuum. It has to be feeding something. If it's not feeding anything, why? Because it's hard. You'd be hard pressed to make an argument, Cuban, of mining minerals in space and then bringing them down to Earth. Why would you do that? What's the point of that? Now, one could make the argument that you could make Earth post-industrial that way. Sure, you could, like, you know, if we're mining asteroids, then you don't need to mine the ground, for sure. But also, at the same time, the sustainability argument is a supplementary thing to the space program. If you try to make that your main thing, you're going to end up doing nothing. Because the most sustainable way for a space program to operate is not. Look at the SLS program, one of the longest NASA programs, save for the shuttle. See what I mean? You got to be you want to build out an architecture to build infrastructure on other planets and explore other planets, and then the asteroid redirect mission comes with that. I.e., if you could do a flyby, if we could make a guidance system to do a crude flyby of Mars, if we can make a guidance system that good, we can make a guidance system to do asteroid redirects. But I say design for Mars first. And everything else, that's what I mean about you're planning around your program's final destination. The final destination for the Artemis program, and I know I keep saying that and people think the movie. Hopefully nobody dies like that, right? The ultimate destination, we'll say that instead, for the Artemis program is Mars. That's it. So the Artemis program is really tooled around a rocket that's designed to go to the moon.
Discovery, go at throttle up.
And an architecture that's designed to kind of stay around at the moon. Where's the architecture with SLS that's going to come in the future that we use to get to Mars? It doesn't exist. It doesn't exist because we got fooled again. I don't trust space programs that are ambiguous about their final goals. You know what I mean? Hey, Vulcan. Hey, I know that giant upper stage. Vulcan, I was talking about using that as your transfer vehicle and putting a crew module up here and have an EUS with your a big crew module that's the size of the universal stage adapter with a docking ring inside of the at the very top. So, you know, this thing gets into space, right? You shut down this, you still got fuel. You jettison the universal stage adapter, it re-enters, right? You plop off Orion. When you jettison the stage adapter, the OSA goes, right? That pops off too. And then just like how Orion was supposed to pluck stuff off of the EUS, you don't pluck it off the EUS. It's just you make your transfer vehicle now. Orion serves as your guidance, navigation, and control. Interfaces with the EUS, which is a capability that we know. And then you deploy solar panels out the side of your proverbial space station module here. Boom. Mars transfer vehicle. One launch. Easy peasy. Well, not easy peasy. But, you know, it'd be really easy to prototype this type of thing by doing free return trajectories around the moon. And in the meantime, you can work off boil-off experiments. And then do lunar flybys. Do lunar flybys with a free return trajectory or distant retrograde, like what we saw in Artemis 1, right? And then use that to do Mars transfers, work on boil-off mitigation more and more. And then after that, because you figured out how to do boil-off with like a sun shield or whatever, you're using hydrogen and oxygen, right? Then you can work on ISRU, and then you can work on circularizing around Mars, and build. Then you have a space station around Mars. You have a little mini Skylab around Mars. It's not rocket science, man. I mean, it is. Why does insulation not stop boil-off? The sun, Dean. You need a sun shield. Yeah, anything that's in direct sunlight up there goes to like 227 Fahrenheit, and then it goes to minus 227 in the dark. You're dealing with a gigantic temperature thermal gradient right here between the dark and the light side of stuff. You go through a lot of heat cycles up in space, and the hard part is that there's no way to get rid of it. Unless you have radiators, there's no way to get rid of the heat. It'll just stay there, and it'll just keep getting hotter and hotter and hotter and hotter until it melts. That's actually been a very real study recently, though not with the Ascent EUS. It'd be a second EUS stage with a single engine for deep space operation instead of the Ascent vehicle configuration EUS. Let me see if I can find it. Yeah, Vulcan, I don't know if I like that. Developing a kick stage for the EUS is just baggage, dude. Make this into your transfer vehicle. I'll be honest with you, dude. I don't really like the EUS. It is great for exploration. For like scientific probes, this thing would be awesome for doing deep space missions. You could do stuff like Voyager 1 in half the time if you launched it that big on that big of a launch vehicle. You could do stuff like Parker Solar again. You could do New Horizons. You could do all these great missions. You could do something like Lucy or Europa Clipper or Psyche, and you could get the science done in half not even half. You get it in a third or an eighth of the time, right? A 3-stage SLS using 2 EUS stages. Okay. Armchair rocket scientist here. Stacking another EUS on top of this, dude, I think you're going to run into longitudinal moment oscillations. If you make the thing too tall, it'll start doing Kerbal stuff. Sending me the study on Discord. Copy link. Anyway, we'll build our post-Apollo vehicle here in a second. Vulcan, what I want to work on today is building that. We found a PDF about post-Saturn V and Nova rockets. I'm gonna build that. I'm gonna build a scale version of that in KSP. Yeah, chunky Saturn. Chunky. Oh, Vulcan, I don't know if you knew this, dude. First of all, long time no see, man. I hope everything's going well. Dude, Aerojet Rocketdyne built out something akin to like McGregor in the 60s in Sacramento. Aerojet Rocketdyne has a gigantic, or had, the HOA actually chased them out, which is hilarious. Very California thing to do. Aerojet Rocketdyne had a gigantic rocket testing facility here, like as big as McGregor. And then on the north side of it, dude, check this out. We did some detective work. See all these buildings right here? What do those look like? Those look like test stands. What do those look like? Blast shields for propellant tanks. Because they are. See where the propellant tanks were? This was... Dude, they built out the entire M1 rocket engine test facility. And they were doing gas generator tests with the M1, which is a Hydrolox vacuum optimized F1 motor. It's the second stage for this project. 3 M1s. They built the whole thing and started using it for like a year, and then it got canceled. It's very discouraging. Dude, can you imagine a Saturn V? You got a Saturn V rocket, dudes. No 5J2s in the second stage. A single M1. A single M1 will do it. Yeah, a single M1 would... Yes, it would be higher TWR. You'd actually be increasing the throw weight on a Saturn V if you put a single F1 in the second, or single M1 in the second stage, and then use the J2 for the S4B. I gotta stop. I'm gonna get annoyed. I gotta stop. I'm gonna get pissed. Damn it. All right, let's see what this PDF is. Dude. What do we got here? Future mission capabilities enabled by an evolved NTP power space launch system. Oh. Oh. Oh, yeah, no, no, that's a good idea. Yeah, we should do that. With an NTP upper stage. You didn't tell me it was nuclear powered. Yeah, I see why they would stack one on top of the other. Yeah, yeah, make that into the transfer vehicle. No, you're right. Good call. Yeah, we should do that. We should do that. So the insulation on the sun side would serve to insulate the tank into staying warm. Well, you wouldn't want to heat up your sun shield too much, Dean. So what they did, and this is what they did to manage thermals during the Apollo program, is you put a shield over your hydrogen tanks, a gigantic sun shield. You could be MLI, Mylar wrap, whatever, which is basically the same thing. And then you rotate the stage. So this is the pill bottle that you rotate it like this, and you keep it 90 degrees to the sun. Right, so if the sunlight is going this way, you roll the thing, right? And that keeps your thermals nice and even. Can you link that one in chat? Oh, Vulcan, can you link that? YG, what's up, man? I can't stay long, but just wanted to pop in and get your feedback. So there are 3 options with the pillow. 1, shipped to the PO box. It will be there next Saturday. 2, I can send either CVS... You can send it to CVS or Marshall UPS store into the hot. Just send it to the PO box, dude. If you insist. Yeah, PO box, man. Thank you. Mac's doing better today. I hung upside down for a very long period of time yesterday, and I got seasick from it. I used to hang upside down all the time in high school, like the playgrounds when I was spend most of my days. Now hanging upside down gets me sick. Getting old sucks. It sucks, dude. Speaking of packages, it's time to open the one I sent. I can't wait any longer. Okay. Hung upside down, or you're a bat. Yes. Okay. I'll go get it, Geek. We'll open it up right now. We gotta play Kerbal. We'll play KSP, but no! Try to make it about you. Part of my pants are transparent. Cool. Cool. If you want to see more of that, you can check out my OnlyVans. ejsa.space/onlyvans. Not safe for, it's NSFW. Not safe for wrenches. All right, Geek. What do we got here? What's that you got there? You got me a birthday present. I don't know why you got me a birthday present. I don't buy you a birthday present. Our keys. Keys are good. What do I do with them? No, it's not keys. Very good. It's set up to go to the P.O. box, so I'll leave it at that. You know, the post office is the only agency that can deliver to a P.O. box. So shipping that causes... Huh. Oh. An engineer, I'm getting there, dude. I can't really move quickly, but I can move. Hmm. Hmm. I'll be holding on to this, Geek. Thank you. Yeah, I don't hate this. Hmm. This is a STS-1 flight overview manual. Yep, the paper smells exactly how you think. Oh, yeah. Wow. Where the heck did you get this? At least show the centerfold. Ah, I can't show that on stream. Is it signed? I don't think that it's signed, but it has a photocopy of John Young and Bob Crippen's signatures. I don't think that's signed. I think it's just a photocopy. Oh. Oh. Yeah, this is pretty cool. It's a map of the Cape. Yeah, I'll be holding on to this. Thanks, man. Got the protective cover. Figured there might be some info in there that you like. Yeah. Yeah. Yeah, probably. Yeah, I would say that is a fair assessment of the situation, man. That's super cool, dude. Thank you. Appreciate you. All right. Let's get to work, shall we? What's your favorite piece of space memorabilia that you own? I can't tell you. My favorite is the one you guys don't know about. What? No, this isn't some like, oh, no, I seriously. No, we're good. Is there a bird in here? It was Starbase Live. What's my favorite piece of memorabilia that I can tell you about. I got thermal tiles from Starship. You guys know about that. Bird. Burp. Yeah, I got thermal tiles from Starship. Those are pretty damn cool. I have a piece of the mobile launcher. I have a piece of one of the mobile launchers that was scrapped. Nova, I think it was Nova. I think Nova, or RJ got me that. I forget. It's sitting on my shelf over there. I got a bunch of stuff, dude. Guys, like, I don't really collect memorabilia, to be honest with you. Like, this is all stuff that's been given to me. I don't really go and seek it out, dude. Like, and I told Charlie Duke this off stream when I was talking to him, when I had the privilege of meeting him in 2019. I told him, you know, I interviewed him and he's like, "Do you want me to sign anything?" I'm like, "No, I don't. No, I'm good, man. You don't need to sign nothing. I got to shake your hand, dude. That's nah. I'm good. The memory is what I'm after." And he was like, "That's cool." He's like, you're the one of the first people that's ever said that. I'm like, dude, I don't need that, man. We're good. Because now the reason why I did that was, I mean, would I like a signature? Yeah, sure. The reason why I did that is because when we were at Space Fest, dude, there were a bunch of people that were there that were just there to get the astronauts to sign stuff so they could sell it on eBay. There was a bunch of eBay resellers, and that pissed me off. I didn't like that at all. Yeah, I didn't like that at all. Like they're, you know, all the astronauts are up at panels, right? And there's a line of people. There's people in line to visit them, and you know, the guy in front of me, and we didn't show it on stream. Saber didn't film it because I told him to turn the camera away. The guy in front of me had like 50 things, and he made Charlie Duke sign 50 pieces of memorabilia. It's like, that's not all for you. That just made me really upset. I didn't like that at all. So when he asked, I'm like, no, I'm good. You've done enough signing today. I'm good. It really pissed me off. And I think that's the reason why he went and played Kerbal with us later, like during that Space Fest stream, because I didn't ask for nothing. I don't need nothing from you. You already made my day 1,000 times better. Oh, Bree's calling me. What's up? You're on stream.
I'm going to the beach.
Okay, bye. Yeah, it really pissed me off. I didn't like that at all. But anyway. I don't know if you heard her. Bree said she's going to the beach. I'm like, all right, bye. That's why a lot of people only sign one thing. Yeah, Creation. I didn't like it at all. Charlie Duke played KSP with you. I launched my Saturn V rocket for him, and I brought up the Aero UI and showed him the telemetry and showed him KSP and how I go about conducting it and how I teach people about it. And I had all the orbital parameters up and stuff, and we had the Aero UI open, and he was watching it. Like I got to see him lock in, which just made my day. That VOD's out there somewhere. I think it's on DOS's channel. Or Vectors or something, or whatever Vectors is now. I saw him lock in. I saw him watch, you know, if you guys go see that VOD, I'm trying to fly the rocket, then I'm looking over. I'm like, does he still care? I'm like, oh crap, dude, he's locking in. He looked at the orbital parameters, and I got to third stage cutoff, and he was like, that's not right, you're short. And I'm like, I'll use the RCS. Yeah. Dude, he locked in. The guy didn't say a word. He was just like, so I could see his eyes like moving around and reading all the numbers. I'm like, what the heck did I just do? Yeah, dude, this is on video. Like, there's a VOD out there somewhere. Can you link the VOD? I don't know where it is. It's around somewhere. Yeah, dude, you should have had big timed him and said, well, actually, it's 2/3 scale. I told him that Kerbal. No, that's the thing, Panta. I told him that Kerbal was like that. I said that before we did the VOD. I go, they keep the planets smaller, so you don't need to build as big a Delta V rocket. Like, you don't need a rocket with as much characteristic energy. And he understood that. He understood exactly what I was saying. And I told him where parking orbit is, etc., etc. Like, I prepped him on all that stuff, and he understood. Charlie Duke understood the assignment. He wasn't saying I was short because he thought it was real life. He was saying I was short because he understood the Delta V requirements for KSP, for low carbon orbit, and saying I was short of LKO, which just, I was like, ugh! Yeah, he was just watching it. He was just looking at the numbers, apogee, perigee, altitudes and stuff. He's like, yeah, you're a little short. I'm like, I'm sorry, Dad, I'm sorry. You know, like, yeah, it's out there, dude. But yeah, I didn't, so, I mean, it's a cool conversation, but I don't really collect spaceflight memorabilia. All of the spaceflight memorabilia that I have is what you guys send me. And I would say I'm like this even if I wasn't streaming. I don't need a signature from any astronaut. I think I asked Mike Massimino for a signature once on the shuttle, on my shuttle manual, and he did sign it. But it didn't feel right. It just doesn't feel right. I don't want to be that guy. I'm like, hey, can I have a signature? You know, like, I mean, it's cool to ask, and if you're cool with that, that's just not my style, dude. I'm after the experience. That's what I want. I want to learn. I want to pick your brain. I want to talk to you about space. I did this with Garrett Reisman. I've interviewed him. I interviewed him at Intrepid one time. Charlie Duke, you met him? Yeah, I streamed KSP with him, Cake. Yeah, we played KSP at Space Fest 2019, dude. Oh yeah. You collect memories. They're better than memorabilia. Yeah, dude, I don't want to be that guy that's like, oh, well, you know, because I know people, guys. I have a signed Charlie Duke. I don't need to do that. I don't need to flex. That's not my style. I'm after the stories like this because that's cool. That's much better than a signature in my mind. So, yeah, guys, I don't really have much spaceflight memorabilia. The stuff that I got is stuff that people gave me. I mean, Bob, it's the same way with like ball players and stuff, like, or athletes or whatever, dude. Like, if I like ran into Tom Brady or something, I wouldn't ask for a signature. I don't want that. Dude, guy brought me 20 years of joy. Like, I don't need your signature, man. I just want to talk to you. Let's talk football. Like, that's what I want to do. Or if I'm talking to an astronaut, I don't need your signature. I don't want to talk about what we have for breakfast. I want to talk space, baby. Let's go. And the best part about that is that when astronauts realize that, when I talk to them, they won't shut up. I can't get them to shut up. The one time I ended up asking an astronaut something stupid was not asking an astronaut something stupid, but a cosmonaut. I met Sergei Krikalev, the guy that got stranded on Mir in 2014 with Sawyer. We met Sergei Krikalev, and because the language barrier was so nuts, like, we ended up talking about VR headsets or something. I don't care. I got to meet Sergei Krikalev. Whatever. That's cool. That just made my day. Seriously, it was awesome. Freaking honor. The last Soviet citizen. Yeah, dude, I shook that guy's hand. Can you believe that? That's crazy, dude. What is Das's channel on YouTube? It's Kerbal Space Academy, dude. Hang on. Let me see if I can find it.
I'm Das, and we're gonna go
He
on a
is
virtual
Das.
field trip today. We are
That was Das's. There you go. Yeah, see, on Das's channel, the VFT that I did from Pima. That was right. That was at the same exact time. So they should be right here somewhere. That's Kerbal Help Desk stuff right there. Yeah, see? That's me sitting in front of a hind. Why? Yeah. That's pretty neat. Swash plate. I'm checking chat. That's swash plate. So it would have been during Vector. It would have. Okay, so it's not on this channel because it would have been right here. Hang on. Give me one moment. I gotta find it. I don't know what they renamed. Vector's VFTs was renamed. They named it something else. I don't know what it's called. Hold on. Maybe you can ask Victor. Yeah. What's our vector, Victor? So this is what Das and I were doing before Das started doing stuff for NSF. We would go around and do VFTs. Like, dude, we got into places. We really we got into places we really shouldn't have been. Here, take a look. Like, we had no business being there. So how's this? Check this out. Like, this is, I can't find the other video, but that's a B-52. It's B-52 serial number 3. Third B-52 ever made. Or third production B-52. That's not including, like, the YB-52. What's that? Oh, nice. See that? That's the pylon. That's the 5th pylon on a B-52. That's an X-15 drop pod right there. Balls 3, or serial number 3, was one of the B-52s that the Air Force was using for the X-15 tests. Neil Armstrong dropped from that pod in an X-15. Yeah, I know, Dean, right? Yep. That is B-52 SN3. That is the X-15 drop pod that they used to do, the Air Force used to conduct tests in the late 1950s. Neil Armstrong dropped from that pod when he was in the Air Force before he became an astronaut. And it's funny, if you watch the whole thing, I realize what it is and go, you know, I start making funny noises. Oh, there's a MiG-29 right there. I wonder... Oh, yeah. Cool t-shirt in that VOD. Yeah, I wore my B-17 shirt. I wonder if this is the VOD where we find the thing. So there's a Thor missile right there. It didn't have the H1 in the back. It was blocked off. See? It was just sitting on a flatbed. Just a whole Thor missile. Whatever. Hold on. That's a Gloucester Meteor wing box. I don't know what it was doing back there, but yeah, we went all looked in it. It smelled like coyote piss, but it's probably because it was coyote piss. But we dug in anyway. Good afternoon. How's the back? Pretty good. Yeah, Gloucester Meteor, one of the first generation English jets. Oh, this thing. That's that's a Titan II missile silo NTO trailer. And then hang on. Hang on a minute. It's Pima. You could just leave this stuff outside. It's really not a big deal. Oh, yeah. Here we go. Here's the best part. Note me running away. Just... I don't need no signatures, but I've hugged an LR87. Have you hugged an LR87? Yeah, Titan II missile engine. You hugged one? I have. You haven't? Did it hug you back, though? Oh, yeah. Yeah, it left all the white paint and schmutz all over my shirt. See? 4 of them. 2, technically. LR87 was 2 engines acting as 1. So it looks like it's a RD180, like a twin nozzle, but it's in fact 2 engines. That's 2 LR87s. And look, all of its turbine machinery. Those are really nice shower heads. What engines were they used on? Those are Titan II missile engines. There's there's the mount piece, there's your impellers. I don't know nearly as much about this stuff. I didn't know nearly as much about this then as I do now. Those are your impeller systems. So, Tessa, this is what I'm talking about. An LR87 is 2 motors acting as 1. They called it the LR87. The LR87 is 2 LR87s technically together as one thing. The reason why it's classified as 2, even though I call it 1 engine, it's technically 2 because you have 4 impellers. 1, 2, 3, and 4. There's 2 impellers for NTO and 2 for MMH. Probably build a working one from all these parts. They were in pretty good condition. I mean, because they've been sitting out there. There's your motor mount. That's the gimbal mount right there. I tried to twist the impeller. It didn't work. I'm going bananas because I'm standing next to injector plates. Filter. Gearbox. There's the gearbox. Yep. Fun fact, LR87s, because it was a gearbox driven, your impellers, because hypergalls, you could run it off whatever. LR87 is one of the only engines that's run on kerosene, hydrolox, hydrolox, and hypergall. You can run anything through an LR87, you just got to change the gear ratio in the gearbox. See those gears right there? That's a valve. Big old valve. The Bobcat engine in KSP is what that's based off of. But yeah, the Charlie Duke video is out there somewhere. I don't know where it ended up. I'm kind of bummed. I don't know where that thing... I don't know where it ended up. Might be gone. Oh well. They invited me back a couple months ago, dude. Actually, about a month ago. I'm going to try one more thing, and then we'll look for that. We'll start building that rocket. Dude, man, that channel that's there might be gone. I'm trying to see if I have it in my subscription list. Give me one sec. Nope. Yeah, I'll have to shoot DOS a message, dude. Did you go back to PM stream? Yeah, I would love to do more VFTs. We should do NASA spaceflight VFTs. I'll ask DOS if, you know, that's something. I mean, that's something we should be doing. Nah. I don't know where it all ended up. What is a VFT? Virtual field trip. Live streaming from a museum. Yeah, that's what we used to do. We used to go to museums and we used to live stream it. It was fun, dude. Good time. Just get to nerd out about stuff. You get to sit there and talk with the museum docents and stuff. We do. I mean, Intrepid is the one that we ended up doing the most amount of work with, but yeah, I don't know, man. It's gone. But, doesn't matter. It's alright. Alright, so, let's, good conversations. Now we're warmed up. Let's do this. Alright, so, this is what I want to make. This is a post-Saturn launch vehicle. We need to make something that's 450 feet tall. First stage is 65 and a half feet wide. Second stage is 60 feet wide. So that's 65 is basically 20 meters, basically. And then this one is like 18 and a half with a 60-foot wide fairing. As far as I can tell, it's a fully expendable vehicle. First stage has 18 F1 engines in it. Second stage has 3 vacuum optimized M1s in it. The thrust is 32.4 million pounds of thrust. That is double super heavy in the first stage. 18 F1s. Yeah, that's double super heavy. Yeah. Super heavy makes 15 million pounds of thrust, or about 70 meganewtons. This makes 140 meganewtons, which is, that's a lot. Oh, nice, Ellingar. You made a model. Neat. It takes, the workflow is not hard to pick up, dude. I'd imagine an alternative timeline where Apollo didn't get canceled and NASA just keeps going. Yeah, that's basically what this is. It's a post-Saturn vehicle, so this is where they were going to go. Where they were going to go after Saturn Nova, which is pretty insane. I need to understand UV unwrapping my models, but then I think I got it. It's like wrapping a present, Hallengar. Think about it. It's like wrapping a present. Try to wrap a present with no overlap. Like, you know, if you actually wrap a present, there is some overlap on the ends, right? Imagine you were just trying to wrap a present. How would you do it with no overlap? That's UVing. It's not that big of a deal. Does it say 18 F1s? Yep. F1As. So that F1As are the Block 2 ones. Those are the ones that flew on the later Apollo missions. So 15, 16, 17. Photos of the COPV that broke have been leaked. It was hardened for liquid hydrogen. How did it break? Dropping it. Bonking it. Read the label on the side, Trey. Look at the bottom line. Do not use if dropped or dented. That's what it says. So, guys, Ship 36, I'm almost positive someone dropped it, or somebody bonked it, or it bounced around in a truck, or on a forklift or something. Like, I'm positive that that's what happened. The more I see. How small is it in comparison to Sea Dragon? It's not that much smaller than Sea Dragon, Jerry. Yeah. Okay. So we're going to make a new craft file here. We're going to get into it. So let's go over here. Flip on the engineering mode. Flip on some tunage. And let's cook. There we go. That should be good. There we go. Testing against the audio, testing against the... Yeah, okay, channels are looking good. Let's do this. Feel like bonking it, though, shouldn't be an issue. Wouldn't forces through re-entry and catch be just as much. No. COP, if you bonk the carbon fiber part of it, Corsi, when they're mounted on brackets. The brackets are on the end, and it's a metal-on-metal connection. The ends of the thing has holders on it has bosses on it that the COPV is not around, because the top part where the valves are, it has to be strong because there's a valve there. There's a proverbial break in the armor. So they make the ends of these things out of thicker metal for that purpose. In fact, yeah, that's not usually the part of the COPV that fails. It's usually in the center, if they do, and you can find it after it happens. Think about it like, what would be a good way to explain this? If you are jacking up an automobile, like if you're trying to get an automobile up in the air and you put the floor jack underneath, like, the wrong thing. If you put the jack on the oil pan, it's just going to cave in the oil pan, because that's not where you pick the engine up from. But if you like jack the car up on a subframe, on a crossmember or suspension, that is designed to hold the car up, so it should be nice. It should be fine. Don't worry about it, Tessa. It's fine. You know what? Let's make a new craft file. Start off with this. Just block piece. All right, so I don't know what we should name this. I don't think this rocket ever got a name, but I already have a Triton rocket. My Triton series of rockets that we built a long time ago were pretty good. I have the Triton rocket is the biggest rocket I've ever made in KSP, and this is going to be pretty comparable to that. I like Triton. We could also bring back the Neptune name. Neptune was a little... Yeah, that kind of was its own thing, though. Jupiter 18. I was going to say we could call it Atlas because we could move the world with a rocket this big, but that Atlas is already taken. Saturn 18. Well, Saturn 18 is... This is a post-Saturn rocket, so it's not a Saturn rocket. It's Saturn-derived. Demeter. Sagittarius. Nah, that's too long for a rocket name. Uranus 5. Prometheus, bring the fire. I do like that. I like Prometheus, because this thing's going to make a lot of fire. You said Uranus wrong? I told you, I don't want an OnlyFans. Go away. Stop talking about that. There goes. Alright. Cool. How about Titan after your dog? I like Prometheus. That's a good name. It's good enough. Jimmy Doohan, because you can't change the laws of physics. Oh, but I can, Tessa. I have the Kraken on my side. All right, so let's get some ideas about what we're talking about here. So, dude, okay. Yeah, this thing is gonna be pretty big. Let me just think about how we're gonna do this. Prometheus was punished by the gods for giving the gift of knowledge to man. He was cast into the bowels of the earth and pecked by birds. Yeah, fire. I know. What is an M1 engine? It's a good question, Hip. The M1 engine, prepare to be amazed and annoyed. The M1 engine is an idea that they were rolling around with in the mid to late 60s. Well, actually, it's part of the Apollo program. Technically, it was part of the Apollo program. What they were trying to do is take an F1 engine, put a vacuum optimized nozzle on it, and convert it to hydrolox. That's what an M1 is. It's gigantic. It's gigantic. The M1 was supposed to be used in post Apollo Saturn applications. So think Saturn rocket has 5 J2s. You have 5 J2s in the second stage, single J2 in the third stage. With the M1 engine, you could have 1 engine in the second stage and then a single J2 in the third stage. 1. M1s. What was the thrust of this thing? Hold on. M1 engine was. It made a lot of power. I'll show you. 1.5 million pounds of thrust. So that is a hydrolox engine that makes almost 7,000 kilonewtons of thrust. Almost. 1,000 psi chamber pressure is actually pretty dog crap, but it is hydrogen, so. Yep. Yeah, they built it. Fun fact. They built the dang thing. Or at least started making test engines. They had the gas generators all engineered out. They just needed to put everything together, and then they canceled the program. That's a picture of the thrust chamber, the throat, and the start of the nozzle for the regeneratively cooled part of the engine. That's it next to a Gemini capsule. It was quite large. So compared to what current vacuum engines move in their ratings, what would a single M1 propel? I don't understand the question. Okay, I think I do. Health issue. So an RL10 that's on the back of let's take the 2 RL10s that are on the back of Vulcan. Each one of those RL10s, that's an RL10CX, at least in the future it will be. Those RL10CXs make maybe 100 kilonewtons of thrust, and there's 2 of them. The one M1 engine has enough thrust, it has the thrust equivalent to 67 RL10CXs, give or take. That thing can do what 67 RL10s can do for almost the same specific impulse. That's the reason why I don't really like the EUS too much, because clustering RL10s is a good idea, but you start getting screwed by the mass fraction once you start clustering them. And they figured this out during the Apollo program. That's why the Saturn I originally was supposed to have 6 RL10s in the second stage. And then they figured out, no, put a single J2 in the upper stage and you save a ton of mass and the vehicle gets really, really capable that way. Oh, Jesus Christ, yeah. So, yeah, that's the idea. How does the M1 compare thrust and chamber to RVAC? So this thing would have had a chamber pressure of about 1,000 psi. Give me 1 second. So 68 bar. 68 bar in the combustion chamber. Raptor So this has 68 bar in the combustion chamber and makes about 6,700 kilonewtons of thrust. Raptor has 300 bar and makes 2,400 kilonewtons of thrust. Yeah, this thing makes 3 times the thrust of a Raptor engine. Could a single M1 move Starship? You'd need 2 to 3. 68 is less than 300. It's an upper stage engine, guys. You don't need to yeet stuff like SpaceX does with an upper stage engine when you're talking about expendable launch vehicle applications. Thrust vector controls provided by gimbaling the entire engine. The specific impulse measure fuel efficiency or how much power could be obtained from a specific unit of fuel was 428 seconds. That's pretty damn good. Considerably more than the 263 from the F1. Well, yeah, of course. Because the M1 was designed to operate in thinner air at higher altitudes, it had a very large exhaust nozzle that was considerably bigger than even the F1. Yeah, this motor was like 3 stories tall, dude. Oh, that's how we figured out about the whole testing site, because there it is. The M1 is way bigger than Raptor. Yeah, you need a gigantic testing stance to get it to work. Yeah, this thing... M1 rocket engine post Saturn. They were talking about clustering M1s down there in an aerospike. Yeah, I'm good. I don't want to do that. There's the test stands. There's the gas generator stands. How do we make a bigger engine in KSP? Well, that's really what we got to do first. You guys know the drill. I haven't done this in a little while. For our post-Saturn Prometheus rocket here, we got to start taking some measurements. That whenever I do something like this, try to transfer something from here into real life, we got to get our scale correctly. Kerbal scale is not human scale. That's different. That is a different thing entirely. So what I want to do is we'll start by making a ruler. Okay, I make rulers for measurement in this game, and it works pretty dang well. Here. All right, so we got to take a strut. Absolute snap the strut there to the world grid. Absolute snap that to the world grid. Now, we got to start getting some dimensions here. Ice King, thank you for the raid. I assume they made the M1 restartable. How do you think they would have done that? I don't know if it was restartable, dude. I'd have to go read. Ice King, what's going on, man? Thank you for the raid. You got gifted a sub. What's going on, Ice King Raiders? How are you? Doing some BD Armory testing. Very good time. Cool, man. All right, so let's go back over here. So let's understand the scale of this vehicle. So it's 450 feet tall. We got to convert that to Kerbal scale, okay? So I'll convert it to Kerbal scale, and then we'll convert it to meters. So 450 feet. Now, Kerbal's running scale, I got this from the developers a long time ago, is about 61 to 62% of their real-life counterparts. A Kerbal is give or take like the size of a small child, basically. So about 60% the size of a real person, right? Like Kerbals are about 1 meter tall. Average person is about 1.5 meters to 2 meters. I get it. Kerbals are all the same size. Like, so we're running about 60% scale. So to get how big this rocket would be in Kerbal, like a Kerbalized version of it, we'd need to times it by about 60, or divide it by 60. So divided by 0.60, or no, times it. I'm an idiot. I got to do it backwards. Times 0.6. So it's 270 feet. It would be a Kerbalized version now would be about 270 feet tall. So now we take that number, that we got to put it into meters. So 1 meter is 3.3 feet. So we got to divide that number by 3.3. And that gets us the size of this rocket. It's about 81 meters long. 81 meters, 81 centimeters. So now we go over here, go to our build menu. We got length, width, and height here. Let's just attach something to the root here. And let's move that this way, and that'll increase the length here. So how big is this dang thing? Okay. So if we go off the front, we go off the back there. That's 45 meters. And you can hold shift and left click, and that'll get you how big this thing is. So we're gonna do 82 meters. So that means, let's take this in another 10. Now, if you're using absolute snap and you have snap to grid here, if you hold left shift and move, one click is 10 centimeters. Or 10 centimeters. 100 mil. It moves in 100 mil increments. I screwed that up. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18,
Discovery,
19,
go at throttle up.
20. So 84. So we'll go in another 10. That's 83.1. And now this one was already moved in. So that should give us 82.1. And then if we take this and we just click them in, move that one in a little bit, and then move that one in one tick, 81.7. Perfect. That is the size, or the length of this vehicle. Hey, Craft Crackers, 82-month resub. Thank you. How did you decide to convert feet to an imaginary measurement and then convert to meters? 60%, 60 to 61%, depending on the part, because the parts were made by, a lot of these parts are made by different artists. 60 to 61% should tell you is your Kerbal scale. That's your running scale. So whenever I build real stuff, like that reminds me, if you guys saw all the builds that I did, if you guys watched, I think it was Tuesday or Thursday's stream when I played KSP and I showed off the planes. That may have been Wednesday, I forget. All of my planes are built to the exact same scale. So if I have, in game, if I have my U2, the U2 that we made in game next to an F-15 in game, they're the same scale. They would be the exact same scale of the real life counterparts. All my planes are built on the same scale. So they're all, like if you fly them together, or if you have them next to each other, they're all the same scale. Heck, even my Saturn V's, some Saturn V's that I made are the Saturn V, the space shuttle, My 747, I all built them at the same running scale. It's 60%. So they all scale to each other. Actually, an 81.81 resub from Craft Crackers. There you go. Yeah, yeah. Getting the mod hanger extender, get the mod hanger extender, it adds unlimited building space in the VAB. I don't need unlimited building space, dude. I can build what I want in here. We're good. Yeah, Urban, I've been told that I'm a little bit of a shuttle connoisseur. All right, so now this is where this part's going to start getting a little weird, because we're going to need to figure out how big the second stage is. And then we got to figure out how big the first stage is, and that's kind of, we're kind of guessing, unless they give us some lengths here. So we know that the first stage diameter is 65.5 feet. Second stage is 60 feet. And the vehicle is approximately 460 feet, including payload. I did 450. What's the difference? If it's 10 feet longer, that would be 3 meters longer. So we'll do 1, 2. And we'll round up a little bit. 1, 2. There you go. 82. No, that's not right. We just... $460 feet divided by 3.3 is 139. Times that by 0.60. 8363 is what we're looking for. So move that one that way. All right, so let's one more tick out there and one more tick that way. 83.7, that's good enough. 8363, we're fine. So that's the length of this vehicle, the overall length of the vehicle. Let's see, what other information can we pull out of here that we can use to scale? You boys are excited for this Kerbal Stream, Rarest? Right on. So we got a first stage diameter of 65.5 feet. So let's take that measurement and we'll go from there. So 65.5 times 0.60, 39.3 feet. Now divide that by 3.3. $11.9. You're building it sideways, of course. I only build in the SPH, dudes. I do not build anywhere else. Actually, you know what? Before I get that one done, let's do the other one. So 60 divided by, or no. 60 times 0.6. 36 feet in Kerbal scale. Divide that by 3.3. And we get a 10.9 meter second stage. That's our second stage here. So we take this, we go up with it. That right there is the diameter of our second stage. Feeling any better? I'm surviving, dude. Thank you for asking. Okay, so that's the diameter that we're talking about here. What's wrong with the VAB? Smaller? The camera sucks. I hate the camera in the VAB. You can't do this with a camera in the VAB. Everything I build is in the SPH. Rockets aren't fabricated inside of VABs. They're built horizontally, or engineered or manufactured horizontally and then assembled in a vertical building. I don't like using the VAB because it's the VAB. It's a vehicle assembly building, not a vehicle manufacturing facility. Differences. No, it doesn't. I mean, Starship is built vertically, but that doesn't matter. The cameras in here are a lot easier to use. You can move your camera around. You can have it focus on different parts. With the VAB, you can really just go up and down like this, and then rotate. You rotate around a centralized focal point. So you really can only do like this kind of work. You can only rotate the camera around one centralized axis. I hate that. It's really difficult. It's really difficult to build anything useful in there. How's the back today? It hurts, but I'm getting there. Sorry for the off-topic question. From you guys? Nah. Did you ever hear when astronaut John Grunsfeld called into Car Talk? Yeah. I have a van that stops after 17,000 miles an hour. I've heard that, dude. Yeah, that was pretty funny. It could be 12 feet if you round up the numbers. It could be. So KSP scale would be 83.7 meters. 60 times 0.6 gives me 36. Divided by 3.3 to get meters is 10.9 diameter. I always like to make notes. 65.5 times 0.6, 39.3. Divide that by 3.3, gives us an 11.9 meters first stage. All right. You're restarting big? I thought this would be a cool project to jump back into, RT. Have you ever heard of the Greek hero? No, I have not. Both of these. Yeah, no. I haven't, Panta. Why don't you tell me about it? EJ, why do you build like this? Am I missing something? What do you mean, why do I build like this? I'm building a scale replica of a real-life rocket. Do you want it to look like this, or do you want to try to freehand it? Freehanding it is... I'm basically setting up the template so I know how big this thing is. I do all my builds like this, guys. Yeah, so for the uninitiated, if you've never seen me play KSP, I do all this out. Last in KSP notes, length. These are my personal notes. You don't need to correct me for those. I always build this way, guys. I build scale. If you're building the scale, you need to build a scale. You got to build a scale replica. That's how I get my stuff to look really, really nice. Like, no, don't worry about it, Secret. It's all good. Yeah, you don't need to correct that. Those are just my personal notes. I don't think you guys can even see that if you're watching it on a phone or anything. Like, so. Like here, check this out. This is an Avro Arrow. I built this on a jig, too. What I do is I make a frame jig, or just a jig for the piece, and then I build the plane on it. That's how I figure out where everything lives, and that's how I can make such accurate builds. Like this Avro Arrow. That Avro Arrow is in perfect scale if we put it out on the runway and we put it next to any of the other planes that we made for Wings Wednesday, like an F-14 or an F-15 or even the F-16. We can, even my English Electric Lightning, the EEL, if we want to put it next to that, it'd be the same scale. Everything is built exactly the same scale. And damn, does that thing go fast. I forgot how fast we made this thing. Dude, we could make this thing look so much nicer. What sort of tank and construction are you thinking this time? That's going to be a lot of tankage. I'll build it like Neptune. We'll construct them like Neptune. Tanks wrapped around tanks. Like we did with Neptune. That's the right way to do it. We kind of get screwed by mass fraction, but we don't need as much delta V as you do in real life, so it's not that big of a deal. And just as an added bit of fun, for an added bit of fun, we'll I'll design it hierarchically so you could theoretically make a launch pad for it. That's probably something that's never going to happen, but I'll design it that way. Why is it called the Electric Lightning? It uses jet engines, both actual question, but also Kappa. It goes fast. That's why it's called Lightning. It's an interceptor. Show me a MiG-19. Do you have one? I don't, Sintesi. What would happen if you made the mass fraction match KSP's scale? The rocket would be insanely overpowered. Wondering if you have ever messed with RSSRO. Not on stream. Why do the Kerbal vehicles drive in a constant drift? That one's not. Hey man, they're working. Leave them alone. Are we going to do some sort of Skylab Eve flyby? No. I don't have a MiG-29. I never made one. Yeah, see, all these jets are the same scale. I don't know why, but I put weapons pylons on the F-14. Thought it looked cool. Landed on the boat. How about we go back to building the rocket that we were building? But every one of these started with measurements, guys. So that's the point that I was trying to make. Everything started with measurements. Yeah, that's just how I do things. Heck, even when I'm building my own type of vehicle, like I'll still use measurements to make shapes and stuff. You can, if you take 2 cubic octags and you connect them via a strut and then you move them around, you can get a straight line. It's like having rulers. It's like having rulers in KSP. It's like using CAD, and that's what I do. Do you use same vessel interaction to get the swing wings to not flop into oblivion? Not with that F-14. With that F-14, the robotic is strong enough. The wings still do flex a little bit though, but the real one does that too, Taco Bell. So that's why I was kind of cool with it. The real F-14 wings do that. Like, you know, you watch Top Gun Maverick where he pulls the wings and he pulls up and splits the throttles, right? And the wings go forward. During that type of maneuver, you are going to get some wing flex. It's just kind of inherent to the design. It does that. That's what the real one does. So it's a little bit exaggerated in KSP, but don't get me wrong, my F-14 isn't flapping its wings like that, dude. Are you the real Backman? I don't know. Maybe. So that's pretty much the diameter that we're going for here. If they didn't flex, they would break. That's right, Ohm. Yeah, exactly. All right, I'm going to make another ruler here. I'm going to start getting us some diameter lines here. With Kerbal, you can actually be pretty damn precise if you're using absolute snap. You can, because with absolute snap, you can move everything in nice round numbers. Using the world grid snap, right, makes it so everything is basically, you can make things like distances between parts. You can make it a nice base 10 increment, right? Because the incremental movement when you're using left shift, right, and absolute snap is 10 centimeters. That's 10 centimeter right there. Same with that, same with that, same with that, same with that. Hold left shift, you get the smaller increment, and you can move stuff very, very easily. So, what I'm going to do, I'm going to take this one, and then I'm going to move this ruler this way. And I'm going to take another ruler, and then another Lamborghini. I'll put the other ruler on top of it. Absolute snap those, so those are on the same increments. And now we know that from the back end of this strut to the back end of that cubic octag strut, that is the diameter that we're looking for our second stage, 10.6. So now we line everything up. The bottom of that strut is marking that perfectly. And then if we gizmo this all the way up here, all the way up into position, the top of this should split the top of the cubic octag in the exact same way. See? The top of one strut is the top of the strut down there, it measures where the bottom is, and the bottom of this strut up here measures where the top is. So now I have some measurements to work with. We have some stuff to play with. Pretty cool. Now, if we want to take this even further, a good way to do this would be to measure so we can move this around. So if we want to, for instance, find the center line of where our proverbial stages are supposed to be, I'm going to make the outer tank walls on this rocket out of fairings to make it look nice. I can make it look like the exact one. We'll just use fairings to kind of hold it all together. We'll have clusters of tanks and we'll wrap them in a fairing to make it look nice. I'm pretty sure with the amount of thrust that this thing has out back that we probably won't need to worry about making it that way, like doing the mass fractions that way. But like, because that way is very mass inefficient, but it's fine. And Tessa rulers were a good idea, Tessa. Yep. After a long time, I feel like I want to play KSP again after seeing EJ do it again. Was pretty pissed off, but now I'm looking forward to it. Wally, we needed to let it simmer for a little while, dude. Not gonna lie. All right, so let's take this here, and let's find our center line. So we're gonna take this sucker like this. Watch, ready? Put that up here like this, and then I'm going to attach. I don't want to attach that part. Let's just use actually, a structural piece probably wouldn't be the worst thing to screw around with here. That'll do it. This piece will do us just fine. So now we need to find the center line of these things. So what we do is we move absolute up here somewhere, right? And then we make sure that's snapped to absolute. And then I get a ruler, one of my rulers, place that there, snap that to absolute. Place another one of these there, same deal, right? I'll tell you why I'm doing this in a moment. So I'm gonna move this up here. I'm gonna make sure that that lines up. Then we move this down here. Now, actually the right way to do this would be 2x radial symmetry. So 2x radial, right? Snap this like that. Now we know that that's perfectly lined up with this. So we just take this, because it's in radial, it'll move the other one. There you go. Now see, I noticed something here. Look, we're not lined up exactly, which means this one That's not exactly right. It's an odd amount of spacing, so we are going to have to round that. Not by much, though. Yeah. Yeah, Peter, I saw it, but I'm just... I don't want to talk about it, man. So, yeah, okay. I see why this is weird. That's measuring the inner diameter. So if I take my original ruler here, we move this. Yeah. I should have done this off of the center point to begin with. Yeah, see, that strut's going through, and that's not exact. It's an odd, that diameter could be a little bit difficult to get the exact spacing right. Give me 1 sec. I'll figure this out. We'd have to get this thing to move on a 5 centimeter increment instead of a 10 centimeter increment. Already running into a fun challenge. All right. I'm thinking. Okay, I got an idea. All right, let's go here. Take this, move that over there like that. Get a 1 PT hydraulic cylinder in single symmetry. Right? And then we take this thing, right? We attach it to the bottom. Attach it to the bottom of the hydraulic cylinder, right? And then it's a cylinder. Then we take it and we absolute snap that in the position that it would be in if it was attached to here. Now, we have a problem. We can only move in 10 centimeter increments, but it very much looks like I need to split the difference here because this strut up here lines up perfectly. That's the outer diameter of our tank wall for our second stage right there. That one lines up perfect. It should split. The one down here, it doesn't. So, what we are going to have to do why not use left shift to use smaller increments? Left shift moves in 10 centimeter increments and I need something to move 5 centimeters or less. These pieces are in symmetry. Okay, so first thing I'm going to do is move this down one. Now that gets that thing pretty much aligned. now, if we take our target extension and we set that to 0.05, that gets us 5 centimeters of movement. Whole thing's got to go down a little bit. Yeah. So okay, we're gonna round numbers. The hydraulic could be used for that, but it's gonna be easier to round the numbers out. I'll get us as close as we can to nice and square here in the square hole. See if we can snap that absolute down 1. Yeah, see, there's a little bit of a difference. So, I'm thinking how we're gonna do this. Trig can fix this. I don't even think we need to get that crazy, dude. Second stage diameter is 10.6. We just need to find something. Well, we split 10.6, we get 5.3. That 0.3 is what's screwing me up. Because you can only, if we're in 2x symmetry, you can't move in a 5-meter increment. So if something was in symmetry to that 5.3, right? Yeah. Huh. That's not gonna work. Scale it up to 11. No, this is solvable. This is an easy problem. Why not round down to 10 meters even? We could round up. I'd rather round up to 11. Rounding up to 11 would make this, well. Yeah. Thanks, Hand Banana. It's my background AI music. See, now it's split the difference. Now we're even. Okay, I figured out a better way to do this. Don't put that there. Put these here like this. Take one of the rulers, put a 1 PT hydraulic cylinder in it, put the 1 PT cylinders in radial. So if I move one, it's going to move the other, right? Set the 1 PT cylinders with a 5 centimeter offset, and then snap this to absolute. That should get us exactly what we need. All right, you know what? I'm not confident that that's right. So let's measure diameter this way. These I-beams are 3 meters, right? That's a 3-meter I-beam. It's 3 meters long. The smaller I-beams are 1.5 meters, right? So now, if we got 10.6, which means we need 5.3 meters of I-beam here. So the first thing we got to do is take the beams, and we got to make sure they're touching each other, so the diameter is drawn from the same point. So that's a 6-meter diameter there, right? And right there, you gotta gizmo them into position. So that's a 12 meter diameter there. We're looking for 10.6. So that's 12, 11.8, 11.6, 11.4, 11.2, 11, 10.8, 10.6. There you go. Just move this back into position. That gave me 11.2. Interesting. There's no other parts in the way, right? Nope. Hey, Carson. Don't panic. What's up, man? That is 11.6, so it looks like my previous measurement was incorrect. So let's move these back. Let me snap those onto the center line here. Move this thing forward, right? And we'll actually move these back this way, a ways. This might work. It may have been that I just, using the ruler, screwed it up. So we're in 2 times radial. Then we move these out here and see if we can get that strut line to line up with the I-beam. There we go. We halved it. Excellent. Now, I know what people are wondering. Why the heck are you doing this? So I can get my fairing diameter. Easy. That's all. That's it. That's the reason. So right there, because we're centered between them, I got it right. It's just using that workflow, using the ruler to get the diameter was impeding me. Now I know what you're saying. They're clipping through. Well, the I-beam, you get length measurements not from the shape of the thing, but from the collider. If you look, see how my mouse is over the I-beam, but it's not selecting it? It's because the collider ends at the very top of the strut. And down here, the collider on this beam ends at the bottom of the strut. So the outer diameter, or the outer wall of that strut and the outer wall of this strut is where my fairing needs to be. So let's save that. We got that right. Now we don't need the beams anymore. Just leave them. So here's a little trick. So how are you going to get a fairing? Well, let's we're going to need a big fairing shell. Let's get the biggest one. Why not? Biggest one can go that big. That would a 5 meter would probably be more or less what we're looking for. We might be able to get away with it with the 375 shell. Yeah, we could. I'll use this one. So now, I'm not going to make the tank, necessarily. What I am going to do is if we go in here with the fairing thing and we turn off toggle snap angle, you know what? Give me the 375. I hate it that the 5 meter fairings have these like weird inaccuracies. When you go to like make a sharp edge, it kind of makes it all wavy. I find that doesn't happen with the 375 fairings as much. I have no idea why. Yeah, it did it a little bit. If you make it too steep of an edge, it doesn't like it. So there you go. Right there, that establishes our second stage diameter. Now, with this kind of, let's call it an aft dome for our second stage, right? Now we know what we can play around with tanks. We can play around with tank size and what fits and what doesn't. Right? Now, what we should do is I have my second stage control node right here. Just move that here. And now, once again, we can figure out how we're going to place the fuel tanks and whatnot. Pretty cool, huh? And then later we can, well, not later. We could play around with engine config here at this point. So the rocket is supposed to have 3 M1 engines. Now, let's play around with scale here, once again. So an M1 engine makes 1.5 million pounds of thrust at 428 second specific impulse. We can scale those numbers. We're going to have some trouble scaling it with specific impulse, but we can scale the thrust. So 1.5 million pounds of thrust is it's about 6,700 kilonewtons, I think. Pounds of thrust to kilonewtons. $6,600 kilonewtons. 6,672. All right. So let's go into our quaccumulator here. 6672 times 0.6. Damn, those engines are powerful. 4,000. Rhino engines are about the right size for what we're trying to do here, dudes, to be honest with you. We could take these things, you kind of gizmo them into place, so make it look like it. It was supposed to have 3 of these, but then, like I said, 3 of these motors. The Rhino engine, scaled for Kerbal, Rhino, we need an engine that makes 4,000. These only make 2,000. There's a trick. There's a trick that you can do here, right? See the thrust limiter? All right. Watch. To get the right scaled component, or to get these engines to perform how we want, let's just take a Cal controller, right? And we'll do what's called a Kerbal meta called Cal overclocking, right? So take the controller, right? We open up the editor, right? We name this Rhino OC. We'll call it Rhino-M1 overclock. Then we go in here. We select the Cal controller, right? And we add thrust limiter from the 3 engines, right? Add the thrust limiter from the 3 engines, and then we just if you take the line here and you just put it up enough, put this in the center, value 136. That's not what I want. We need that value to be 200. $187. $249. But let's move this way. Keep adding points in and just move this thing around until we find 220, 210, 203, 202, 199.18. Perfect. Right there. Copy that curve, set it to the other ones, move the Cal controller, activate it, right, and then go back. Now our engines are producing 200% of what they were producing before. There are trade-offs to this. You can make any engine have as much thrust as you want. The big trade-off that you have to deal with now is the joints in KSP. You can make an engine have 10,000 kilonewtons of thrust if you overclock it to the moon with the cow controller. You can make any engine have any amount of thrust, which is really cool. That makes it so we can give this the exact amount of engines that it has in real life, because we can scale the engines a little bit. As long as we find an engine that relatively is performing similar to those motors. The Rhino engine is one of the most efficient engines in the game. 340 seconds specific impulse. That is very, very efficient, especially for that much thrust. That is mostly analogous to the M1. It's pretty close. That's pretty good. Now, the real M1, once again, our motor is 4,000 kilonewtons at 340 seconds vacuum. That's okay. Pretty damn good for KSP. The real one is 6,700 kilonewtons at 428 seconds specific impulse. So the scale kind of lines up. It's pretty, at least from the specific impulse standpoint, it's pretty, that's about right. That's good enough. Now, here's the thing. The engines will gulp down fuel. We're going to need to give them a lot of fuel. Remember, we got to make this thing go into space. What's its payload capacity? We got to figure out what the payload capacity of this vehicle is. Payload is 980,000 pounds. Okay? So we go 980,000, right? To go pounds to kilograms, it's divided by 2.2. So divided by 2.2, that gives us 445,454 kilograms to low Kerbin orbit. Now, that's what that number is without the scaling. Now we take that number, times it by 0.6, right? And that gets us our payload capacity. Our rocket needs to have a payload capacity of 267,272 kilograms in Kerbal with a 18-meter fairing. Or, no, not an 18-meter fairing. That is a 10.6 meter fairing. So we need 300 tons with a 10.6 meter fairing. 267 tons. So is 267 T. So we'll work around that. So those actually line up. Those are M1 engines, I'm pretty sure. But for gameplay purposes, they probably adjusted the thrust output because an M1 engine in this game would be insanely overpowered. Just like the shuttle engine is ridiculously overpowered. Why doesn't SpaceX just do this instead of adding so many engines? Because manufacturing big stuff like this does take time. SpaceX made an engine that's easy to manufacture and easy to transport. You could just put a bunch of Raptors in a trailer. They're easy to move around. It's easier to manufacture a bunch of small engines, Jonas, than it is to manufacture a couple big ones. At least right now. That's the way it's basically been since the Apollo program. The reason why is, on top of like physically moving, how are you going to move this? How are you going to move around an engine that's 3 stories tall? Because that's how big an M1 engine is. Up here at the top, they have renders of what this engine is supposed to look like. There you go. The engine is almost as big as a Falcon 9 second stage with its motor. That's just the engine. We're talking a scale here that's just unheard of, dude. Right? So SpaceX opted to make a smaller engine and cluster them together because it's easier. And they're right. They're absolutely right. It worked for Falcon, works for this too. You have better engine out capability, Toctic, for sure, with 33 engines. But there's always a trade-off in engineering, guys. The trade-off is that getting 33 engines to jive together and be happy is a little bit harder than getting 3. So there's always a trade-off. SpaceX, remember, with SpaceX and with Starship, it is really centered around manufacturing. Because with Starship, one of the stakeholder expectations, so one of the overall goals of the Starship program is to be able to make a rocket that's mass-produced. That is absolutely playing into their design. That's part of the reason why Starship is made out of stainless steel, for instance. Because stainless steel, easier to manufacture. It's easier to manufacture it. It's easier to make rings. You can just churn out rings all day. And SpaceX also, if you guys notice that Starship is made up of a bunch of stainless steel rings that are kind of stacked on top of each other. Another thing that SpaceX did was they made their stainless steel ring size the exact diameter of an off-the-shelf roll of stainless steel. So they wouldn't have to do any modifications to the steel. You could just buy it. You could just buy it wholesale. That opens up the ability to mass manufacture because it's just a regular old stainless steel roll. Sheet metal is made in rolls, like string. It's made in a roll, and the ring sections on Starship are the exact same length as the roll, or width as the roll. So SpaceX can the ring building station basically just has one of these spools basically turning, and they turn it out and they turn it into a ring and weld the end and then send it off to wherever it needs to go. It makes it easier to manufacture. That's just an example. Making smaller rocket engines that are, easier to manufacture, like Raptor 3. Raptor 3 is a good point. Raptor 3 is going to be an extremely difficult engine to service because you'd have to take apart the whole engine if you want to work on something. But you can make a ton of them. And for SpaceX, making a lot of Raptors, right, mass producing Raptors, makes it that if a Raptor 3 does have a problem, they can just swap it. It's not a big deal. SpaceX swaps out Raptor 2s all the time. So remember, one of the stakeholder expectations one of the goals for the Starship program,
This is space. I'm in space.
Hey, you just gifted a sub to cold salted butter. Thanks, man. One of the design criteria, it's called stakeholder expectations in systems engineering. One of the stakeholder expectations for Starship isn't just being a fully reusable launch vehicle. It's a fully reusable rapidly reusable launch vehicle that can also be mass produced. That is playing in to how SpaceX tests things, guys. That's what I mean when I say like Ship 36 blowing up. It does suck, but it's not a big deal in the scheme of things. You know why? Ship 37's right over there. The real trouble here is that they blew up their test stand. Seriously. Build another one. Because that is one of the goals. One of the goals of the Starship program is to be able to make a lot of these things and make them quickly. Got to remember that when you figure, when you take into...
This is space. I'm in space.
Nova Raptor gifted a sub to Chick-fil-A. Nice. You got to remember that when you're thinking about how SpaceX is going about solving these problems. Everybody's saying, they've had 4 failures in a row. They're screwed. Who cares? 4 failures is nothing. Starship isn't supposed to work like that. Obviously it's not supposed to work like it's not supposed to explode. But 4 failures in a row, when you're trying to make something that's mass produced, you guys got to remember these 4 failures have happened in less than 6 months. Think about that for a second. Look at the overarching thing here. Starship has almost launched 10 times since 2023. Since late 2023. 10 flights almost. That's ridiculous. That is ridiculous. There's a much bigger thing at play here. The bigger thing at play is that, when Elon says he wants to launch a Starship, like he wants to be able to launch a Starship every hour, that's what he means. If you want to be able to launch a Starship every hour, that's not just about making a fully reusable vehicle and then getting it to work. That's about making a fully reusable vehicle and building a lot of them. Part of rapid reuse, and this is what makes airplanes so nice, part of rapid reuse is that, with airplanes is that you can work on them when they get to their destination. You can fix things. If you have some fixed base operations at whatever airport, you can fix it. It's not a big deal. Right? Airplanes, they're easy to fix. They're easy to maintain. They're easy to work on. Any A&P is looking at me now going, yeah, no. But you know what I mean, right? It's not like you're working on a piston radial engine, right? Like working on a Wright Cyclone. Working on a CFM56 is way easier than working on a Wright Cyclone motor. Like there's the one with like 35 cylinders in it or something. That's extremely difficult to maintain comparatively to the jet, right? Right? So SpaceX, once again, rapidly reusable thing, right? Manufacturing, it plays a lot into it. Because what if you need to swap out a part? You're going to need to make a lot of engines. You're going to need to make a lot of ships. do we think that Starship, guys? I'll be honest with you. I don't think Starship itself will be able to be fully rapidly turned around in an hour. What I think SpaceX is going to do, at least sometime in the near future, is launch a ship on a Super Heavy. The Super Heavy comes back down. They catch it. They set it back down on the pad. Ship does its thing, right? Ship comes back. It lands on another pad. Could be just a catch tower or just another pad, right? And in the meantime, while that ship is going around, SpaceX takes another Starship and stacks that on the Super Heavy, right? The other Starship comes back down and lands, gets caught by the other tower, and then Super Heavy goes again and launches another Starship into space. This is how I think they're going to do that rapidly reusable turnaround. They're not going to use the same stack to do a turnaround. That'd be very weird, right? You wouldn't do that. I think you're going to have multiple Starships, right? And you have a rotation of orbiters. And the only way to do that, to get that rapid turnaround, because there's payload change out, right? Like, okay, say you get a Starship back, you want to launch it again in an hour. Are you putting 20 new Starlink satellites in that thing in an hour? No. The smart thing to do would be to have another Starship that's loaded and ready to go. Ship comes down, gets caught, right? Goes, they take it off, put it on an SPMT, put it on its transport stand. It goes back to Starship processing. And then a Starship comes out of Starship processing, like a Mega Bay or something, with cargo ready to go, ready to stack on the new booster. Right? Think about it. It's basically what the shuttle program was supposed to do with the orbiter processing facilities. The reason why they built 4 orbiters in the first place, guys, was because you're not going to just land the shuttle, load it up with payload, put it back on a stack, and launch it again an hour later. Right? You land one, check it out, takes, like a week or two to get it ready to go, look over everything, takes another week to put payload in, and then, another week to stack the stupid thing, right? And then, leaving a week of leeway time right there. You have 4 orbiters you can launch every week. You can launch 52 times a year. That was their idea. Have multiple orbiters and keep them in the rotation. SpaceX, I guarantee you SpaceX will do that. They will absolutely do that. That's the smart move. That's not even like, oh, we're doing that because the shuttle program did it. That's just a good idea. SpaceX already does that with Dragons. Dragons need to be turned around. They already do that with Dragons. It's not the same Dragon flying every time. They have a fleet of them on purpose. So you got to think about that. You got to think about your stakeholder expectations here, especially when it comes to Starship. You guys said it yourself. Super Heavy is 33 engines. If one engine goes, it's not a big deal. We've already seen the fruits of that labor. We've had a Super Heavy put a Starship into space just fine with an engine out. We've had a Super Heavy do a boost back burn with an engine out. They tried to do a Super Heavy doing the landing burn with an engine out, but that didn't work last time. But they'll get it, right? And, if it lands and they're looking over the booster and then he needs an engine swapped out, new one on. The whole system, mass production is incorporated into the entire design for Starship. So in the scheme of things, these explosions mean nothing. They mean nothing. I'm serious. Anybody that thinks like, oh, SpaceX is doomed or something has no idea what they're talking about. You don't understand what SpaceX is trying to do. It demonstrates a fundamental misunderstanding of the state of systems engineering and stakeholder expectations. Big red flag for me. They had a Flight 8 catch with the engine out. Yeah, that's right, Ari. I didn't notice that because I watched Flight 8 land from the Margaritaville Hotel, so I didn't see it I didn't have the UI in front of me, Dan, you used to work on Route 3350 radial engines on the P2V Neptunes. Things had like 18 cylinders and they were a pain. So much intake and exhaust baffling in the way. Yep. So SpaceX is the reason why SpaceX opted for 33 engines and 6 engines on Starship instead of like 5 engines and 1 engine on Starship. 5 engines on Super Heavy and 1 engine on Starship. It's just easier to make smaller motors. You can manufacture a lot more of those smaller engines, right? They're smaller to make, easier to manufacture, right? You can make a lot of them, and they're easy to transport. Stakeholder expectations of mass production playing right into the design. Now, Vectors are a little bit more difficult to move because they are bigger, right? They're more difficult to move. They're gigantic. But you don't need as many of those as you do need as regular Raptors. A Starship stack will end up having 42 engines. 6 of those will be vacuum engines. All right, no problem. But yeah, think about that when you look at Starship. Starship's designed that way because of the rapid reuse and mass production. A vehicle like this was probably not designed for that. I would guess something like this, fully expendable vehicle, but you can move 450 tons into Leo in one shot. Sorry, I'm stretching my back. Moving 450 tons into Leo in one shot would not have as high a flight rate as you might think. 4 times a year, maybe 2 times a year, something like this. Smaller engines also means a shorter interstage. Yeah, to an extent, yeah. Anyway. Question. What if you lifted just the ship with the Pad A chopsticks to stack height, no booster, hook up the ship quick disconnect, and do a comparable propellant prop load to a landed ship to do a 6-engine spin prime in midair? And just be extra careful and look at the past Block 2 static fire data to ensure Ship 37 is safe. Why would you want to risk your launch pad? What if it does that again? Then you lose your launch pad and then you're really down for the count. Erudite, you guys got to get out of your mind that Massey's is going to take a long time to rebuild. It's not. It's just not. Everybody seems to think, oh, they lost test stand. They're gonna be down for like 6 months. No, you have no idea what you're talking about. They built that entire site in 2.5. Nah. They'll have it up and running in a month. Even Ryan Weber agreed with me when I had him yesterday here on Space News. Anyway, so that's gonna get us that right there. Now, I don't necessarily have stage length here. We don't have that figured out exactly yet. So what I'm going to do, we're going to take that. We're going to take our control node here. And I'll put a control node back here for the second stage length. We got to make sure that that control node is aligned so we're on the same center line here. There we go. Cool. Now we'll just move back a little ways here. And now we got to figure out our first stage diameter. First stage diameter is 11.9. Well, the reason is they are willing to put a Block 2 new QD in for 2 more ships. Why wouldn't you do that? You already have one. They have one left over from suborbital Pad A. It's already been made. It's already there. Why would you? Why? Why not? SpaceX could literally rebuild Massey's out of spare parts. Remember, because they had 2 suborbital pads. Those pads both had a Starship umbilical on them. And the one that was on there, the one that got blown away in the Ship 36 test, was the one from Pad B. In fact, a lot of the paraphernalia at Massey's was made out of leftover parts from the suborbital testing site. But remember, they had 2 of those. So that means we have spares. We have functional spares of a lot of those parts. Tanks, vaporizers, whatever. Like, that's what I mean. Massey's is not going to take very long to rebuild, guys. Really, it's not. Okay, so let's get into... So that... No lyrics. We need instrumentals. Okay, cool. So that's 3 meter. Move that one down. We're looking for an 11.9. So take my root part, move that up here like this. Now moving this down should give me what I need. 12.4, 12.2, 12.0, 11.8. Nice grab. I'm getting the measuring sticks out. Yep. That's what I'm doing, Kuja man. Damn, this thing's big. The height is 11.7. And we needed 10.6. That fairing isn't right exactly. I just needed to. I need to check one more thing. Let me get a 5-meter tank here. So that would be two 5-meter fairing or two 5-meter tanks. That would be 10 meters across. So if we move each one 10 centimeters out. So that's 10.2, 10.4, 10.6. Oh, yeah. Yeah, it's too big. The first fairing was too big. I screwed up. I don't know what I did wrong. Hey, Red. What's going on, buddy? Alright, get rid of that fairing. I don't like it. Pissing me off. Okay. There we go. That's right. I don't know. I must have looked at the wrong number. Psych! That's the wrong number! Oh! Anyway, would they produce more ships than boosters in the future? Probably, Cake. Yeah, absolutely. Ryan did agree with me, yeah. Ryan thought it would take 4 months. I think it's going to take less than a month. Seriously, I don't think it'll take very long. Yeah, Battle, I'm getting there. I mean, that's reading at 10.9. But that's because the top of the cubic octags are screwing me up a little bit. If we move them down, right? So the top of the octag is basically aligned with the tank wall there. It gives me about 10.6. So that means that that strut mark right there, these strut lines are exactly where that needs to be. Cool. I'm glad that I double checked it. Now is the time to be careful with those measurements. So now what we can do is we can get our, that is our upper stage tank wall. That's where that's going to go. Let me get a 375 fairing, because we know that's going to work. And we'll just make a dome piece. Okay, that's our second stage tank wall. Test article right there. I hate that the fairings get finicky like this. Bro, it's straight doming it. What's up, 95? How you doing, buddy? Why did you remove the rhinos? That other fairing wasn't correct, Dean. I'll add them back in with the cow controller and everything. That takes 2 seconds to do. It's important to get your measurements right. I'll be honest, guys. Like, if it was just me, I wouldn't even really be putting engines on. I'm just doing that to help give you guys some visual aids as to what the heck I'm doing. Okay. Yeah, I should probably smooth that out a little bit. Okay. That's our prototype. Prototype aft dome for our second stage. Let's just move that over there, and then, you know, Dean, what we can do, I won't set the OC, the overclock for the engines, just yet. We're going to need to do a lot more testing with this to make sure that this is all structurally sound and stuff, but I'll put them on there to make it look cool. Okay. All right. So there's our test upper stage piece right there. I'll move its master control node just forward because that's going to be over here somewhere. And now we work on the first stage. Rotate those back up into position. And we're looking at 11.9 here. Cool. I'm going to set it a little bit higher. We got to take into account the height of the cubic octag relative to the bottom of strut. That is 11.9 between the struts. It's 12.1 total, which is no problem. Easy peasy. Okay, so now we can get rid of the beams that we were using for measurement, and I can do the same thing. Give me another 375 fairing. Right? Move this back a little ways. Not a lot. And now we could build the aft dome for the first stage here. There we go. First stage half dome. Dunskies. This thing has a 2 meter longer diameter than Super Heavy. Yep. Thanks, Fluffy. Yeah, I'm all right. I just got to stretch my back. Hey, Joe, what's going on? We'll be part of Flame Trench tonight. Yeah. Yeah, I'm good. Actually, let me check in with them. Yeah, Carson, if you're out there, yes, I'll do it. I told NSF guys that I might not be able to be upright for the Flame Trench, so, yeah, I'm good. We are upright. What kind of payloads will this thing send up? Well, 95, I don't know. What I'm doing is we found a PDF from the early parts of the Apollo program. This is from like the early 60s, so like 62, 63, 64, somewhere in there. I think actually this one is from 1964. Yep. This is dude, first of all, I never realized that they were doing this. Second of all, they were trying to figure out what vehicle they were going to use after Nova. Like, they already had, you know, Saturn 1B, Saturn 5, right? And then, you know, Saturn Nova. And then what are our rockets going to look like after that? What are rockets going to look like post Saturn once we get to the moon, we build a moon base? We're going to need a rocket with a much bigger throw if we want to explore the stars. Something that Elon echoes with Starship. You got to build a big rocket if you want to actually go like and colonize it, not colonize, like explore stuff, right? So this is a post-Saturn launch vehicle with 18 F1s in the first stage and 3 M1s, which is a Hydrolox vacuum optimized F1 engine in the second stage. 32 million pounds of thrust. 32.4 million pounds of thrust. That is twice. That's double Super Heavy. Double. 450 ton throw to Leo, which is... EJ could hang from the inversion table upside down. I'd probably puke, dude. I know about Saturn MLVs, Kai. Yeah, that's what I thought they would do, but that's those ML... the Saturn, that's not post Saturn. Those are Saturn iterations, the MLV. So a thing that they could have done with the Saturn V is attach 4 Titan 2 or 4 Titan 3 boosters to the side. So a Saturn with 4 Titan SRBs on the side. Like, you could have done some damage with that, but this is like totally post Saturn. Like, where are you going to go when you've hit your theoretical max for Saturn and Nova? That's what these rockets are about. The plans didn't get much further than a couple of these drawings because they were like, oh, Saturn V might be enough, right? So, yeah, pretty crazy. Hey, Ollie, what rocket are you looking at? It doesn't even have a name. It's just called Post-Saturn Class 1 Baseline. I call it Prometheus in KSP. I'm building a scale replica of it to Kerbal scale to work with to be a functional equivalent in KSP in KSP's universe. Yeah. If you look, this rocket would have been gigantic. Look at the Kerbal next to that's my first stage diameter right there. How I build rockets, guys, is if it's a weird diameter that's not one of the diameters in the game, like 5 meter, 375, 2.5, 1.8, I'll make it out of fairings. I'll make the diameter of the vehicle, the tank wall, out of fairings, and then I'll fill it up. I'll fill it up with tanks, and we'll clip tanks into each other that are of equal to or proportional volume value to the amount of air, volume inside of my tanks that we made. Call it Prometheus. What's up, Space Pope? So is this rocket going to have an eagle that's going to peck at its liver for all eternity? Sure. Post-Saturn, Sea Dragon. Yeah. No, that's not what I'm making here. So we need 18. What is the engine section for this thing gonna look like? Do the Mastodons even make a equivalent thrust here? I don't think they do. Let me think. Have you ever used the symmetry bug? No. I know what it is though, 95. I just don't use it because you're asking for a Kraken strike. Symmetry bugs screw with hierarchical values, and you're tempting the Kraken doing that. So we need 18 of those, huh? Nice thrust puck. Oh, thank you. Well, that's 18 right there. I'm trying to think of how the engine, like, you don't really see what the engine configuration is supposed to look like here. I would assume it's somewhat circular from the picture there, but how else would we get or 18 of these? That's 2 rows of 8, which is 16 plus 2 in the center. You guys said 3 rows of 6. That actually gave me an idea. Groups of 6 at 50 degrees. So that's 12. Yeah, a row of 12 and a row of 6. There you go. That's it. That's 18 engines, right? We have 12 on the outer, 6 on the inner. That's 18. Yeah, I like that much better than the other engine configuration. This is a lot more clean. Damn, dude. What a monster. Ursula, I'm naked! That's, I don't know. It's the thing. Give me a liter of cola. See, the other thing is that this makes a lot more sense. F1 engines had to be spread out. You can't cluster F1 engines close together, guys. They had to be spread apart. The reason why is if you put them too close to each other, all the heat convected off the outside of the engine, the heat given off from the outside of the engines will melt the components on the other sides of the engines. That's why on the Saturn V, they were wrapped in asbestos. The motors on the way up, they actually just wrapped them in asbestos so they wouldn't melt each other from the inside out, or from the outside in. What is the biggest rocket you've built? The biggest rocket I've built would be Triton, my Triton series of rockets. This will be bigger than Triton. It'll actually be wider, and these will probably be about the same size. I thought it was metal. It's asbestos. The Triton rocket I never really got fully working. This is Triton. Triton is manufactured in a similar way. And it has... It actually has a very similar amount of engines. Yeah, very similar amount of engines. How does Starship not tilt completely around on re-entry due to a lot of forward weight when the tanks are empty and mostly only forward tanks are full? That would shift COM forward a lot. Yeah, it shifts it forward, but it shifts it into the center. The closer they can get the center of gravity to be equidistant between your control surfaces, the easier control you're going to have, Brem. Problem is, rockets and stages are naturally tail heavy. The reason why they're tail heavy is because you can't put the motor up in the front like on an airplane, right? You can't put the motor in the center. Well, you could, but that would propose its own kind of problems. Rocket engines, for physics reasons, like, feeding them fuel, usually are at the back. But at the back makes something tail heavy. Now, with the shuttle, how did they solve that problem? You got 3 big engines back there. They solved that problem by giving it a straight delta wing and shoehorning as much mass as humanly possible into the front of the ship. That's why it has a thruster block up there. Crew tank is up there. Water tanks are up there. All your control systems are up there. The avionics are as far forward in the shuttle as possible because you had to counteract the moment from having rocket engines attached to the back. Starship overcomes that same problem by doing the exact same thing with different components. Starship shoehorns as much stuff into the nose as possible. Your forward control surfaces, your header tanks, anything. COPVs, we know that. They're as far forward, almost as far forward as they can be. Because Starship needs that fuel in there to land, right? But that doesn't really matter when you're going to actually land, right? Because the thing flips over and then you turn the engines on and then it lands. Center of gravity just needs to be straight. It needs to be plumb up and down with gravity for it to work correctly. But when you're going through re-entry, you use the fuel as ballast. Now, the shuttle didn't use any fuel as ballast. It used components for ballast. It used components to to even this thing out because it doesn't need fuel to land. It lands on a runway. Starship, a little bit different. Starship needs fuel. So if your fuel makes really good ballast, we know because look at all the locks that was in ship 36 yesterday, or 2 days ago. Technically 2 days ago, but technically yesterday too, depending on where you are in the world. So Starship uses the fuel up there. It doesn't shift it too far forward. It shifts it into the center. Those header tanks aren't nearly as big as the main fuel tanks. And they're just fuel tanks, dude. The engines, the Raptor engines at the bottom, have way more mass, dude. It doesn't shift it too far forward. It trims it out. Does that make sense? Fuel goes away though. I just explained that a moment ago. Damn. I know that fuel goes away. I understand. Is Starship firing its engines during re-entry? No. No, it does not. It fires its engines when it lands. Where the control surfaces stop working and it flips over, right? The landing burn. That's when it's using fuel. You use it to ballast out during re-entry. You're not firing your engine then. Right? Can't say me, I received 2 3D printed space shuttles today. Woo! Nice. Were you ever going to launch Triton? I never got Triton to work. Maybe once or twice. And then... So, I overclocked these motors on this. Dean, this thing is a scale... That's super heavy. That's what that is. It's super heavy, but a more Kerbalized version. I ended up giving these motors like 6,000% of their thrust to get this thing to work correctly. Problem is, when you overclock engines in KSP, you start running into physics and strut problems. For the same exact reasons why they do staggered ignitions on rockets when they turn the engines on. Like, Starship doesn't fire all 33 engines all at once. It kind of staggers the ignition. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Like, think of like a torque pattern, right? Like if you're torquing down a tire, that's how they activate the engines. The reason why they do that is because if you activated them all at once, it would shock load the bottom of the vehicle and it would crumple. The whole vehicle would blow up. It would be like hitting, if you turn on all the rocket engines at the same time, it'd be like hitting the bottom with a gigantic hammer. Yeah. When you overclock engines in KSP, you start running into that same problem. This thing has so much power out the bottom with all the overclocked engines that I ended up needing to implement a sequence ignition. I never did that though, because I didn't understand what sequence ignition was when I built this. When I built this thing originally. So, with that being said, I got Triton to fly once or twice, and I got it to fly really nicely, just out of straight dumb luck. We'll build Prometheus out to fix those problems. But yeah, I think that's our engine configuration. 18 F1s in the first stage and 3 M1s in the second stage. In KSP, couldn't you just throttle up slowly? In KSP, Nils, sure. Yeah, in KSP. You can't really do that with a rocket engine. Not all rocket engines are deep throttleable. F1 engines absolutely were not. F1 engines have 2 throttle settings, 0 and 100. If you tried to throttle one of these, the whole vehicle would do what ship 36 did the other day. Now, with that all being said, we need to figure out with this vehicle, liftoff thrust is 32.4 million, so it's an 18 F1 motors. So F1 rocket engine. Let's figure out what our motors need to make. Saturn C8. Oh yeah. Anyway. So let's figure this out. Dude, F1 engine makes 7,700 kilonewtons in vacuum. You've got to be kidding me. That is an insane amount of power. That one F1 engine is almost as powerful as 9 Merlin engines, which is crazy. GWR 94 to 1. It's pretty good. It's pretty damn good. 70 bar chamber pressure. Interesting. That's so low. That's crazy. Even for rocket engines at the time. 263 second specific impulse. Like I said, it's about as SRB, as solid rocket booster, as you could make a liquid fuel booster. But what it lacks in specific impulse, it makes up for in characteristic energy. Dang, those things are big. And that's Von Braun right there. The crazy part is Von Braun was not short. He's 6'2". About 190 centimeter. He's a big dude. Anyway. Thrust. 6,700 kilonewtons. So we need to do some calculations out. 6,770. Actually, we'll clear the calculator. 6,770 times 18. $121,860 kilonewtons. Wow. Hang on. Oh, they're F1As. It's 6,900 kilonewtons. $125,820. 820. Try the RP1 mod. No, I'm good. I'm good, thank you. And the M1, we already did the calculations for the M1. 28.2 million pounds of thrust. So this right here, 32.4 million pounds of thrust is all of the engines combined. I don't know why you do that way, but whatever. Okay, so let's take our scaled thrust here. Okay, so we have 125,820 because they're supposed to be F1As. So let's times that by 0.6, which gives us a total liftoff thrust of 75,492 kilonewtons. Now divide that number by 18, and that's the thrust output that's needed for these engines. 4194, give or take. Oh. So the Mastodon engines, so I actually have to do, we have to do a very similar thing that we did with Triton. We need these engines to make a little more staminky, you know what I mean? They gotta make a little staminky. You understand, Chad? I gotta go a little bit faster. So 1350. So let me go here. 4194 divided by 1350. Okay. We would need to overclock this. We need to overclock these engines to 320% of rated, or well, 220% of rated performance, technically. Man, this thing's gonna go. I might opt to do 19 engines instead of 18 to help make sure we're not overclocking the crazy out of these things. So I might opt for 19 for doing a center engine. Guys, one, because that looks cooler. Looks cooler to me. Two, if we ever try to make this reusable, having a center landing engine is probably a good idea. What's the vector range on these things? 5. Perfect. And that'll make it so our overclock isn't nearly as bad. So 4194 divided by 19. Oh, no. 75,492. 75,492 divided by 19. Or no. I didn't do that right either. 7592. Start over. These F1 engines make 6990. There's 18 of them in this theoretical design. That's 125,820. Okay? That's the total lift-off thrust, right? If we transfer that to Kerbal scale, we times it by 0.6, 75,492, and then divide that by the total thrust output of the Mastodon engines in KSP. No, I didn't do that calculation right again. I got streamer brain, guys. Balls. I got streamer brain. I got streamer brain 6909. Okay, so let's just do an individual engine. It'll be easier that way. 6909. Times that by 0.6. That means each engine needs to make 4145 kilonewtons. The Mastodons currently make 1350. Take that number divided by 1350. We need to make three times the thrust rating of the motor. Now, if I take that number and times it by 19, it should get us around 70. Nope, I screwed up. I screwed up again. Streamer brain, dude. I was doing good there for a second, and then I went, duh. The inner machinations of my rocket are an enigma. Basically 300%. 300% with 19 engines should do us right. We might have to dial it in because our mass fraction is going to be a little bit different, but that's ballpark what we need. Dang it, Bobby. Okay, cool. These need to make 300% thrust, and these need to make 200%. There we go. So now we need to figure out, I mean, we got some pretty good hypotheticals here. Now we got to figure out where the heck all this stuff goes. So the first stage and the engine section go back here somewhere. That's the bottom of said vehicle right here. Give or take. Now, does this paper have any word on how tall the second stage is? Because I don't want to sit here and just kind of fudge out some numbers. You know, we need a rocket that uses propane, boy. Oh, I tell you what. You could search the document. Good call. A typical Class 2 concept is shown in Figure 2. Each stage is 70 feet in diameter. What the heck? Wow, that is a crazy... That freaking aerospike thing. Wow. It is 290%. F1A thrust 18 divided by 19, then times by 0.6, divide Mastodon 1350. I think you said that gives you 2.9. Yeah, I said about 300. So 3 times the thrust. Yeah, thank you. I appreciate it. We're going to have to... I wanted to get a ballpark reci because Kerbal mass doesn't necessarily equate out to... Like, tanks are heavier in KSP. They have a terrible mass fraction. So we might even need to go a little bit more, which is why I want 19 engines. 19 engines at 3 times the thrust should get me exactly what I want. That extra engine should give us the kick to make up for any potential crappy mass differences here. Flame Trench tonight? NSF need your optimism to balance things out. Sure. Yeah, with that Class 2 vehicle design, they clustered the engines around a spike. It's a freaking aerospike engine. But it's an aerospike with F1 engines as your spike feeding engines, which is... Whoa. Yeah, dude, this is pretty good. Take the PDF, put it in Grok, and ask for the height. Well, where's the fun in that, dude? No, I want to go look for it, dude. Because you learn something that way. You don't learn nothing if you just tell the AI to tell you to do it for you. That's stupid. That is not a blanket statement. That's stupid in the application of what we're talking about, because the whole purpose is to teach you guys and show you guys the process, not have AI do it for me. I don't need AI doing my job for me. That just gives people like that why would I do that? Rabbit said 420 feet right after the diameter. It's 460 feet tall. We don't get the stage design, so we might have to fudge it here. So okay, my bad. Just trying to give ideas. Nah, no problem, Ari. Don't worry about it, dude. It's just not my style, man. I'm not trying to be a jerk. I apologize. I'd say that first stage is probably 180 feet tall. It's interesting that because the bottom of the stage actually tapers outward, and that's probably because clustering these engines like that can't cluster them that close. So they're probably sitting out on the edge of the wall right here. Having the engines push on your proverbial tank wall makes this thing nice and strong. New Glenn does this. Well, something similar. So that is our engine config. Because yeah, we're gonna have to make it taper. No problem. Would rotating detonation aerospikes be easier to control with the size of these rockets? What does easier to control mean, Erudite? What do you mean easier to control? I don't understand. Oh, Dragon, I hate, like, if you Google something, it puts that text up there that says, well, it's actually this, and that information is usually wrong. Which, I hate it. It's so stupid. Textbook and shitification right there. Dude, I look up all kinds of stuff about cars, like, oh, what's the ignition timing on this motor? And it's like, oh, the ignition timing on a small block Ford is 67 degrees before top dead center. I'm like, no, it's not. That's not right at all. You are 100% wrong. If you set timing at 67 BTDC on a small block Ford, the engine would explode when you try to start it, if it would start at all. But that's hyperbole on my part. You get the idea. You're absolutely correct. Nice catch, ChatGPT. Probably, yeah, I know. I mean, it's not going to be like that forever, but boy, does it get annoying. Can you post a link of the document that you have? Sure. I'll post it in both chats. Did I see your message above? Monkey, if you don't tag me, I just assume you're not talking to me. So, I'll go back and read, but tag me in the future, dude. Yeah. I'm keeping up with 2 chats. I'm streaming on Twitch and YouTube, so I got 2 chats to look for. Tag me if you need to get my attention. With that being said, what's on your mind? Do you like cars or rockets more? Rockets. Have you heard about the WASD main menu? It's a cool KSP mod. You should check it out. I got it. You're new. Yeah, I know, man. All good. That's why I told you. I don't know about the WASD mod main menu thing. I don't know what that is. I'm really hesitant to put new mods into the game, though, dude. I don't want to stack my Kerbal save with 1,000 different mods. So, it's got to be a mod that I kind of need, you know? Thanks for the doc link. Cool. I get to babysit your 3 dogs for a bit. Okay, article. They're not the same document after all. Maybe this is useful. Oh yeah, all the images in this thing are terrible. But this looks to have a more fleshed out class 1 baseline here. Also, do you use some sort of KSP checklist mod to keep track of everything? Yeah. What's the name of that thing that I use, the mod manager for KSP? I don't remember the name. CCAN, that's what it is. Thank you. I'm looking for some specifications on the class 1. That's the same copy right there. First development flight in mid-1972, operational availability in late 1974. Oh, man. Hold on, my back. I'm alright. I'm alright. I'm alright. Oh, you can make like checklists and stuff, Monkey? That's cool. I usually just put anything that I need to know up here. But yeah, that's cool, man. No, I was kind of shifting back and forth going, oh man, come on. And yeah, apparently I probably shouldn't do that. All right, well, we're just going to have to fudge that. I don't think we're going to get a detailed scheme for this, but we can extrapolate some stuff here. So the top of the M1 engine is basically at the 200-foot mark, if we can zoom in here. Top of the F1 with its turbo pumps is actually, yeah, it's pretty much right at that mark, right? So how tall would an F1 engine have been? Go back over here. "25 feet. Okay. So let's go back over to this. Does it look like that's about a quarter of that? It does. So that gives us the taper between the first and second stage. That gives us a first stage, I don't know, 175 feet, give or take. No, it looks like it might be a little bit more than that. You got to take into account that there's a space between the rocket engine and the top of the stage. So I'd say more like 160. Let's say 166, because that looks about 2/3 of the way up. Yeah, so 166 tall. First stage, I think that's fair, okay? So we got a 166 foot tall stage. We need to put that into Kerbal scale, times 6. So that gives us 100 feet tall in Kerbal scale. Then we need to convert that to meters, divide by 3.3, and that gives us a 30.18 stage. Oof. All right, so our first stage from the bottom of the nozzles to the top here is 30 meters. 30.2 meters. So move that down here like this. Move that back up. All right, so we know that I-beam right here, this beam is 3 meters long. So as long as we gizmo these into the right position, like that, and then put another one, and we gizmo that one tick down, that's 6 meters. Gizmo that one tick, 12 meters. That's 24 meters, right? And now you can just 27 meters, 30 meters. And we need 0.2. So that would be 30 meters, 30.1, 30.2. Pretty large. Sorry, I'm just shuffling these around a little bit so there's no gap. All right. So that gives us first stage length, more or less. I'm going to put these on their side so they don't interfere with the design later. So to be clear, you're working post Saturn 1. Yeah. Post Saturn, it's the class 1. Class 1 is what I'm making. I'm making that. The reason why is we could make the arrow spike, but all that's going to do in KSP is just make the engines not work as efficiently because we don't have flow dynamics. There's no computational fluid dynamics in KSP. So I'm not making that. And frankly, the class 3 baseline vehicle looks stupid. So it looks like a party hat. I'm not doing that. This one looks the coolest. That's what we're making. Okay? Is that clear enough for you, man? Cool, thanks. I got you. All right, so the tapered section looks to be about 10 feet. And these things are about 3 meters. So that's my taper section. Where we have a conic adapter, the conic interstage adapter, between the first and second stage is going to take up that much space. Right? And that gets us almost to the halfway mark. The middle of the vehicle is right there. So our stage is running, we're running it, this is pretty right. We're close. We're close to getting this correct. Because the halfway point on the vehicle is right there. Just, yeah, that's good. Okay, so now the second stage. The second stage, dude, that second stage is gigantic. It's bigger than the first stage, almost. And this was using an inner tank design. I wonder what their rationale for that was. It's probably, I think it's explained, but probably manufacturing, to be honest with you. But holy crap. How many streams does it usually take for you to build a rocket this big? If we work on this next week, yeah, I should have it done by the end of next week. That's if I was playing Kerbal like every day. I don't know if we're gonna play Kerbal every day next week. We'll probably switch between KSP and the car, and then other games too. For the last week of Locked in June, the third week of June was basically a washout for me because of my back, but. Hydrogen volume? Yeah. Is it known at what altitude stage separation would happen? I don't think they ever got that far in on us, but this is using Carolox, so you're getting a similar specific impulse as a Saturn V, so I'm guessing staging altitudes and stuff would have been more or less similar to like a Saturn V or even SLS, or even maybe not Starship. Starship is a little bit of a different thing. Stage 2 Hydrolox is difficult with a common bulkhead due to temperature difference. Well, yeah, Kai, for sure. Saturn got away with it with the S2 and the S4B. They're not doing it here, probably for the reason that you're saying, but it's not impossible. That's what I'm trying to tell you. It ain't impossible. Everything is good, Chuck. How's everything with you? I'm wondering if we just take the same length here. Yeah, okay, that was an absolute snapped. That's no problem. Cool. I noticed a little bit of a discrepancy there, but that's alright. Wow. Do you think Kitten Space Agency will be a success and kill KSP? KSP did a pretty good job killing itself, so I think it'll be a success. I don't think they have to worry about killing KSP. You have done that to yourself. All right, so that's kind of the positions for everything. It looks like the first stage and the second stage are pretty much the same size. They're pretty much the same size. This one just has a taper on it because of a different engine. It looks like they manufactured the same tank. Well, a similar tank design. One's just slightly bigger than the other to take into account differential propellants. So like this is using kerosene and liquid oxygen. That one's using hydrogen and oxygen. So that means the remaining incremental area up here can be bearing. The rocket's 460 feet tall. First and second stage don't look aligned. Oh, they're not yet. Don't worry about that. Okay. Okay. Damn, dude. This thing would have been a monster. Hey, Hinris, what's going on? Just got home. Could you give me a quick summary of this build? I'm making that in KSP. It's a post-Saturn class vehicle. This is from a paper that was done by NASA in the mid-60s. And this was taking into account the Impala program not getting canceled. This was done in the mid-60s to figure out what would come in terms of carrier of launch vehicles after the Saturn family of rockets. So, Little Joe 2, Redstone, Jupiter, Juno, Saturn 1, Saturn 1B, Saturn 5, Saturn Nova, right? What comes after that? These papers were quickly seen as not needed. They never even got close to making this. What they were going to make is Nova, but they never did it. So a bit early for it, but if you're looking for payloads. I want pictures. Thank you. Nice. Did you ever finish a Pillar of Autumn? No, Michael, I shelved the project. It's like maybe 30 to 40% done. Sometimes plans change, dude. I wanted to finish it. Maybe we'll do it someday. This is AAP stuff, Aqualex. That's not, this is AAP 1 through 4, so that's Skylab. Have you ever made a Nova or N1 rocket remake? Nova? No. Saturn V? Yes. N1? No. All right. So there we go. That's we gotta just get the fairing right. So the fairing, so we know that's 60 down there. So it goes from about 320. Yeah, I'd say 320 to about 460. 60 divided by 320 gives us a fairing height of 140 feet, which is just absurd to me. 140 feet, divide that by 3.3. That means our fairing is 42 meters tall. Times that by 0.6 to get it into Kerbal scale, we got a 25 meter fairing. Whew. 25 meters. That would be 5 of these things. So we go 1, 2, 3, 4. Yeah. I'd say that is pretty much in line with what I'm trying to do here. That's a good enough approximation. It ends up being a little bit longer. So it's like 26. But that's perfect. There we go. So we more or less now have our dimensions for what we're trying to do. Scaled dimensions, which is great. That's super useful. All right. Excellent. Save. There we go. What's the thrust of the Class 1 compared to the Saturn V? Starship is more powerful than direct descent Nova. Well, this thing has 18 F1A engines in the first stage, Kai. So you have F1 engines make 6909 kilonewtons of thrust, right? Times that by 18. It gives you 124,362 kilonewtons. Plug that in here if you want pounds. Or 362, not 762. Would have been cool if it was that. That gives us 27.9 million pounds of thrust. Super Heavy makes 15 million pounds of thrust. This thing would have been way more powerful than that. We're getting into the territory of publicly available documents that no one has digitized. That's not, the link isn't even loading for me. I remember the old days when you could save from NTRS. Sometimes you still can. It depends on the PDF. EGSC, electrical ground support equipment required for post-Saturn launch vehicle facilities and operations. Oh. Oh man, that would have been sick. Dude, what does the launch pad for this damn thing look like? That'd be nuts. Because you guys got to remember, all right, here, you want to understand scale here. That's more or less a Saturn V first stage. Compared to this. This thing is freaking huge, man. Sea Dragon? I don't think this thing would have been a Sea Dragon vehicle. I don't think it would have launched from the sea. This, from what they're saying, it, given the hardware and the engines and stuff, this probably would have been more GSE based. But that's the thing. The diameter of this vehicle is almost as big as the damn mobile launcher. I don't know what the heck you would put this thing on to get it. You'd need to build a much larger launch pad for this thing. It really depends on what you're looking up, Whoop, to be honest with you. For that reason. Yeah, the launch pads for Saturn were overbuilt. The launch 39A and 39B are overbuilt. They're really designed for Nova. There's no way to prove that. Like, they are. They're designed for Nova. The flame trench is the exact diameter of a Nova rocket. It was built for that. Would you even move it, or would it be easier to move the building at that point? I don't know, dude. Maybe we try to make this reusable, or try to stack it, try to build cranes for it, and maybe we'll figure out a solution for that. This is not going to be a lot of parts, man. So we can use this same diameter up here for the fairing. My control node for the fairing right there. 375. Okay, so the bottom of the fairing would be wherever this flattens out. We got to line it up with that. What a monster. Jeez. Okay. So the cylindrical part takes up probably about, I don't know, 2/5 of the way through. And then it curves from there, and we have kind of a spherical top. Didn't get the angle right. Yikes. Take a look at this one. Okay. Yeah, it's quite large. That's quite a big vehicle. Advanced Post-Saturn Earth Launch Vehicle Study Executive Summary Report. Oh boy. Bruh. Post-Saturn Class 4 with nuclear stage on baseline and Nexus boosters. 8 750 Kelvin water moderated metal core. A nuclear stage. Oh my goodness. This is all the Class 2 stuff. The Class 1 vehicle isn't here. Holy balls. Based on the mobile assembly method, a launch support facility can be used to support either the offshore launch system or a Saturn-type support system. This area would house all of the support operations needed to prepare the vehicle for launch. Individual stage receiving and checkout buildings would permit minimum requirements for the vertical assembly building, as well as major rework, maintenance, and checkout operations are performed in the stage buildings. Assembly of stages and payload and final vehicle checkout is performed in the VAB. Vertical assembly building. They call it vertical. It's vehicle assembly building, but it was called early in the Apollo program. It was called a vertical assembly building. To the point where it was so early that they really never ended up calling that. It's vehicle assembly. Installation of retro rockets, touchdown engines, ordnance items would be made after leaving the vertical assembly. Oh no, I'm misunderstanding this. That's an assembly building. Okay. After recovery, the stage would be purged and placed upon a transporter and transferred to its refurbishing bay. Dude, that's crazy. Reusable. Yeah, I noticed that. Oh my goodness. Can you link this one? Why, certainly. Dude, the Nexus. What the heck is the Nexus? What is that? Is that a kick or what? Like, oh man. Oh, I love it. See? Dude, these guys were doing... Oh, it's so good, man. There's so much cool stuff. Look at that freaking transfer stage. 20-meter core transfer. 20-meter nuclear thermal. Oh my goodness, it's got 7 nervas in the bottom. Or no, 8 nervas in the bottom. Oh. General Dynamics Nexus. Yeah, the other ones talk about this thing too. What is this thing? It looks like SERV. Cool part is that they were thinking of this stuff before the Saturn V even completed its goal. Yeah, I mean, like I said, they had plans, dude. That's such a strange design. It's kind of like SERV, though. The Nexus reminds me of SERV, but with a stage on top. Big. It's big. That's what it is. Yeah. Yeah, I'm okay with this. Dude. Frick Starship, you know what you could do with one of those? You get one of those things fully fueled on orbit. Oh. Nuclear, okay. Delta V, 20,000 feet per second. Oh. 6 kilometers a second Delta V. Okay. Okay. 6 kilometers a second Delta V from one of those things. That's not, I mean, that's subject to change with payload on top of it, but oh my goodness. Why use feet per second? Because this is a paper from like 1965. 20,000 feet per second. Yeah, 6,000. 6 kilometers a second, dude. That thing could just go to the moon and come back. It's really not a big deal. But it says Delta V sub 2. I don't know why are they using the sub 2 there? Let me read for a second. Figure 3 shows a solid core reactor water moderated nuclear stage mounted on a post-Saturn Class 2 baseline vehicle and on a tailored Nexus first stage. Vehicles are sized for orbital delivery, and the booster stages are offloaded to about 75% capacity. This places staging velocity at approximately 10,000 feet per second. That's 3 kilometers a second, 3.3 kilometers a second, give or take. The vehicles are all about 70 feet in diameter. The Nexus has a large diameter ratio of about 7.8, whereas post-Saturn Class 2 vehicle large diameter ratio is 9.3. Post-Saturn Class 2 is 650 feet tall, whereas the other two measure about 550. The nuclear stages of 5.45 million pounds each placed nearly 1.5 million they place 1.5 million pounds. $680 metric ton throw weight, throw capacity to low Earth orbit. 680 tons. Don't stand up, it'll be embarrassing. Yeah, the launch weights are approximately 14.4 million pounds. For the payload fractions are 0.02. That's awesome, dude. We should build that. Hey, New Mark, what's up? Jeepers creepers, dude. That's just that's an insane amount of freaking. What the hell? Huh. How much do one of their theoretical NTRs make? Water moderated metal core engines. Where are those things? They talk about those at all? Hmm. Oh my goodness. This pisses me off that Nerva went the way that it did, because Nerva was only the beginning. And once again, it still blows my mind that they knew this well. It's like they knew exactly what they needed to do and then some. Like it was all figured out. Like how? Like how did you know exactly? Like how did they know like exactly what they needed to make? I understand you do that by doing an analysis. I get it. That's a lot of analysis. That's what I'm trying to tell you. Getting near Flame Trench, yeah. I can't believe that, man. Okay. Dude. Lack of brain rot. Yeah. This frickin' thing, dudes, huh? Wow. This vehicle's gonna be gigantic, man. And this is like the crappiest version out of all of them. Oh. We didn't have a lack of funding, yeah. No. It's not just that. You can throw money at a problem with spaceflight theory and it won't fix it, right? You can do, like, look at SLS. You can throw money at it and it doesn't fix the problem. It's management. You have to, that comes with other things. I don't want to talk about it. In fact, I gotta go to Flame Trench in a little bit, dudes, and I don't want to get all salty before we do that. That's nuts, dude. Look at all the freaking motors. In order to see, now here's what I'm wondering. You know, we'd have to overclock this 3 times the amount. So that means we would need 3 times the amount of engines here. Could we fit 3 times the amount of engines in here? Nah. Nah, that's not gonna work. I wonder if we could take the load off of the overclock by adding more. And these Mastodon engines are very, very light. They have a great, really good power to weight. Nice. That's pretty good. 6. Dude, can you imagine how complicated the plumbing would be for that? It would look like super heavy up in there. Yeah, if you want to be spicy in a flame transfer, this one. What is this, Aqualux? Check the graphics. I don't know. Graphics? Dude, I read the first 3 paragraphs and it pissed me off. I don't want to read this anymore. I'm getting rid of this. Bye-bye. Well, Project Paperclip sure helped. Operation Paperclip. Anyway. Alright, well, it's about time for Flame Trench, dudes. So what I'm going to do, that's going to conclude part 1 here. I have a pretty rough design for what I want. We got our fairing figured out. Getting the fairing to separate correctly, I can already tell, is going to be a little bit of an issue. I have to butt up an inner stage to it, and yeah, that could get a little complicated. No problem. What they were anticipating in terms of forward trajectory.
Discovery, go at throttle up.
Venturius. 3-month resub. I'll read this later. I don't want to touch that. Love seeing KSP again. Yeah, it's a good time. Yeah, we'll, I'm anticipating some jankiness trying to get the fairing to separate, but we should be okay. You went back a chapter. I know. I know, dude. I still have it on my other computer with what you linked with all the graphs. I'm running out of time. Remember last week I was underneath the car and they were like, hey, Flame Trench is starting. So I'm running out of time. So I'm trying to not read that right now because I know if I read it, I'm going to want to keep reading it and then I will be late. So back off. I got it. I got it, brother. We're good. Getting this to stage shouldn't be too bad. Getting the cup to go there. We could just make hollow fairings for that. We could try to do a hollow fairing here. I'm not sure how that's going to work though. But I think we got our post-Saturn Class 1 vehicle kind of sorted. Here, I'm going to get rid of that second row just for now, and I'll leave it with the engine configuration that we had. Cool. And we'll discuss whether overclocking is a good idea or whether we should just add more motors. I think adding more motors might help spread the load a little bit better. It might be easier. Spread the compression load that inevitably happens from all those engines pushing up. That's a lot of force to push up with. Even in Kerbal, that's a lot. 75 meganewtons. That is a lot for Kerbal. 75,000 kilonewtons of thrust. So yeah, there's not really much in KSP that has that out of the box. Can you do a sequenced ignition? Yeah, with a Cal controller we could do it. I could have a sequenced ignition controller with Cal, using Cal controllers. That shouldn't be an issue. We're just going to need one hell of a thrust structure in here, Nader, that's all.
Listen, Tranquility Base here. The Eagle has landed.
Please don't talking Z over Z paperclip operation.
Okay. So that's going to do it for part 1.1 of this. We will continue next week. We'll get this thing built. If we sit down and cook with KSP next week, we should be able to get this done. But I want to do some car work and I want to do KSP work next week. So that's what we'll do. But you know, that's going to stop for KSP now, but stay tuned. We got plenty of stream left. Now, if you're on YouTube, once again, I'm going to shut the VOD off because Flame Trench is on YouTube and I don't want to double broadcast it. So you guys go over to NSF, NASA Spaceflight. That's the NASA Spaceflight channel if you're watching on YouTube. And here, I'll link the YouTube over there for you guys. And yeah, we go from there. On Twitch, though, just chill here for a second. You'll get a momentary loss of signal, and then I should get the NSF countdown timer popped up soon. So there'll just be a dead air signal for a second, and then you'll get the countdown timer for Flame Trench. So thank you very much for watching, everybody. I hope you enjoyed this post Saturn Class 1. I hope you learned something. We will continue it more next week. I will see you guys in a second for Flame Trench. Thank you very much for watching. Stay tuned. Plenty stream left, because we got GTA racing after Flame Trench tonight as well, so that should be fun. So I'll see you guys then. Be back momentarily.